that should be audio. And then people on YouTube should not be hearing any music. And we gotta open up the YouTube stream. Hit a refresh. There it is. And open up the chat over here. Pop it out. Bada bing. Close that. I got a track change immediately. Oh, good. This is that music that FK Productions recommended. Sounds pretty good. Little tech house. I had like a hard pimple or something on the side of my head. It's something that like keeps reoccurring. It might be like a miniature cyst or something like that. But oh my god, it hurts. I popped it again, and now I have like a scab there. It feels like a railroad spike is in the side of my head. But now to help with my little headache, I'm going to turn on a face light. I'm going to put a light right in my face. Nope, that was the wrong one. Well, maybe we can toggle it back on. Oh no, it's out of sync now. Hold on. Lights, face. That Windows update messed a bunch of stuff up. I've got everybody's configured to have static IPs, but oh, I need to get by. This is a no. Too much woobly in that. Woo 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 woo. This track would be very good if it weren't for the woo 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 that's going on it. All right, let me turn this down so there's no echoey feedback. Whoa! Almost had a resistor spill. This thing was upside down in the bins, and it almost spilled its contents of resistors all over the place. My resistors are so disorganized. Tomorrow we are going to do another big book, but we're going to try to keep it simple in order to build up confidence, because I am so sick of building stuff and having it not work. That's why we are working in my wheelhouse, which is reverse engineering today. I have a different method that I would like to use in order to ascertain what the values of what the layout of the circuit is, and we can do that pictorially. I can do that in a way that's more entertaining than just sitting here with a notebook and jotting down what every trace does. We can use visual aids in order to take our brains out of the equation, because our brains are big squishy puddings full of neurons. Every square centimeter is filled with billions and billions of neurons, and so they can mess up. There's no error correction in there. So what I like to do is remove myself from the equation and do this all on the computer. I'll probably end up using MS Paint instead of an actual circuit layout program, though. What up, Beat Drop guy? How you doing? What's going on in the land of beat droppings? that sounds terrible. Beat droppings. It's like leaves and stuff. That ain't no borscht. Those are beat droppings. Drop in the bass. That over there. This is more circuit stuff from our big book day. I'm excited to do something really, really stupid simple with Big Book Day tomorrow. We're gonna take it easy because it's Friday. I need to do some uploads too because I'm only 3 days ahead right now. I'm only 3 days ahead. After today and tomorrow, oh God, what are we gonna do? I'll just keep uploading. I'll just keep throwing stuff up. I can't believe it. I should be done by now if I really did actually concentrate on it. And it's tough because it's a lot of work. I mean, we did one stream where I uploaded it. It takes time, but it's not a lot of work. Like it's not like mentally taxing, but it is like you get tired after doing it after a little while. And you got to listen to yourself talk, which is always an issue. I have a lot of issue with that. You get over it because you're in video production, right? Because what this all boils down to is an entertainment show, and I like to keep it a little bit more cerebral. But in the end, this is supposed to be entertainment. This is what's supposed to pass for entertainment these days. What was the John Cleese quote from his father watching TV going, I don't think this will replace entertainment, which is just such a heady line. There's so much in there. It's just beautifully glib, dry British humor. Underappreciated line from the AMC documentary, Almost the Truth, The Lawyer's Cut, which is a sort of an exploration of Monty Python's career, as they're all super duper old and dodgy at this point. I don't think there's going to be another interview tour. I know the song. Yeah, yeah, yeah. Always with the... Whoa, is this auto-focusing? What the... Whoa, it's really jarring. Arm procedure. Boop. No autofocus? No autofocus. There we go. We're back. We should get all this stuff out of the way, too. I am going to be using special techniques developed by idiots because I can't bother to concentrate on anything for too long. That's what it all boils down to. I don't want to think. I don't want to think. I want everything regurgitated in my face. My dog is 41 pounds for a female corgi who's not big. She's not small, but 41 is a lot of weight. That's too heavy, and the numbers have been going up. So we gotta watch out. That little puppy, she'll still get the same amount of treats, but I think she needs to get either different food or less food. Hard to say no, but, you know. Happy dog is a skinny dog. Not skinny, I mean just a normal weight dog. Oh boy, I have a headache. I think it's just because of the thing that I popped on the side of my head. Luckily, you guys can't really see it. My hair covers it just a little bit, but it is, I don't know, it's just this like open sore. It really hurts. This is a mess over here. It's almost like I pull out the whole oscilloscope and use it with everything else. Let me put that behind. These, the BNC adapters that I've got are a little, the cable on them is a little inflexible, and that kind of hurts my ability to move this around. This is a very FK production style mix, isn't it? It's very, very tech house, and it's got kind of the longer notes and the shorter notes. I don't know how to describe it. It's a vibe. It's a vibe. It's a vibe. You have to be there. You had to be there. Oh shit, it's him! Everybody Scarper, let's get the fuck out of here. He found out. Everybody go in a different direction. There's like 2 people here right now, so I'm trying out that mix that you sent yesterday because it sounds really good. I dropped in on it for like two seconds and I was like, all right, I get this. I get what's going on here. I'm picking up what you're putting down. Nice oscilloscope. It was my big 4.0 gift to myself, and it was like $700. It's not cheap, but I use the scope a lot, and especially for this stream, I'm able to open a web page on my intranet, and it is a clickable, interactable readout of the scope at 60-ish FPS. I don't know what the exact FPS is, but it's enough FPS that if we go into reverse engineering something, and we're doing like a certain particular signal, or like looking for a sudden change in a signal, this will capture it, and you guys will be able to see it in full color. So it was a really huge upgrade. Oh, they do a series. Yeah, I saw that it was like a live stream, and there's a bunch of stuff. I just clicked a random one. I don't know if showing this will get me like a... I got a visual copy strike from the Prodigy video that was the stop motion one, if I showed it on stream. So I'm not gonna show the entire thing, but I will give credit where it's due. Right there. There we go. You can see. Episode 500? Oh, FK, by the way, I was thinking about the toaster oven soldering thing. One thing that I'm sure you're familiar with as, you know, mechanical engineering and stuff is that you need to follow a curve of heating if you're doing it in like a toaster oven without a controller. You don't need a controller to do it in the toaster oven. The controller lets you walk away. And if you're soldering like a 2-layer board and you're soldering 1 layer all at once, by doing like a toaster oven, it's really fun, it's really cool. You make an afternoon of it, you get a good temperature probe, and what you're trying to do is roughly follow the temperature curve. And the temperature curve you can just Google. What you do is you get it, like you slowly get it up to temperature, and then you sneak it over the line. And I guess what that does is it reduces the amount of moisture in everything, and it keeps everybody at a nice, good... You're gonna PIT it. I mean, great, that's great. That's a lot of fun. There's tons of toaster, replacement controller stuff out there. There's even skillet controller replacement. I actually have, where did it go? Whatever. It's in my new tool chest. I have a hot plate for the next time we have to solder something that's like a small board sitting on a plane. Oh, that's right. The failed water cube. I found a picture of that the other day. It was that thing that I built that was supposed to, we put a bunch of heaters in a lot of water, and it was like a PVC tube that went down and the heaters stuck out of it. It didn't really work out all that well, but the PID controllers are pretty nice. So yeah, that should be an easy one then. Oh, that'll be cool. The thing that was sent in by a viewer was this thing down here, and that's got that tiny little window in front, and I don't really know what to do with it. I need more space, as always. I need more space. I would love to do an equipment wall. Yeah, we were talking about putting bagels in this thing. Some infrared thing, and it's got all the timing and stuff on it. But the problem is, when I use it, it doesn't feel like it's like doing the job properly. But what I need like a big like shelf wall where I can put a bunch of this old equipment that I have and like hook it up to something to make it look pretty. Because then I can have the camera on the equipment wall and have all the blinking lights go off. Yeah. It's lead-free solder, Don't tell California. Whew. But yeah, I've got a different toaster oven in here, and it's got a big glass window on it, which is a much more visual thing for me, and that's what I gotta stress, because I have to come back to brass tacks on all this streaming stuff and make sure that I'm actually being visually entertaining. So, putting my crotch dead center on camera while I adjust a fan, that kind of thing. This is Lord David's module. Lord David plugged in his module wrong and blew it up. And then we tried to fix it, and then we plugged it in wrong, and we blew it up. So I got to figure out what the heck is going on with this thing, and I am left with few options here. Actually, we got plenty of options. It's just the option that I think is most prudent at this point is to use a different technique of reverse engineering. And we'll see that today. And it'll help take our brains out of our squishy human brains out of the equation. Because they sure do. They sure are full of fallacy, these brains of ours. Let's get organizing a little bit on here because everything's all crappy. Crotch shots are the only reason I'm here. Did you see Twitch approved a whole new batch of twerking emotes? They're no longer censoring twerking emotes. We've done it. We won. We finally won. Twerking is back on Twitch. I love all the frivolity of Twitch. There's just some really frivolous stuff going on. And people will always mess with the meta. What is the meta these days? You know what? I don't want to know. I don't want to know. I don't want to know what degeneracy Twitch is openly pursuing in a cynical attempt to get viewers. I know, finally. Someone let me out of my cage. Finally, we get twerking emotes. I'm excited for tomorrow because I want to try another Big Book of Circuits circuit. This would be the third one that we try, and this one might actually succeed. There was the fish noise, and then page 572 and page 581. I want to try one of those other ones because for some reason the fish noise did nothing. It didn't do any sort of oscillation, and where did we go wrong? As far as I'm concerned, my ability to check over a circuit, although sometimes lacking, is enough that I can look at that what we put on that page and say, yeah, we represented that circuit pretty well. So why did it do nothing? Unless it's one of these like engineer traps where if I was a little bit smarter, I would know that something is terribly inserviceably wrong with the circuit. But I don't really think that's the case. This completely unraveled itself, didn't it? Thanks for participating in my shop, Cable. This one has a little organizer on it, so maybe we'll just use that. When is your dog gonna twerk? She does have that round rump right now. She got that badonk going on. Hopefully we can put her on a diet. Although, man, that's tough cookies there. 2 years old, almost. She's got like a couple months left. And you're put on a diet. It sucks, but it's less abusive than her getting fat. I don't want my puppy to get fat. I want her to have a nice, because corgis are very active dogs. I think I got to take her, maybe we can both lose weight. That's my goal, is me lose weight, dog lose weight. She's not going to have much of a choice in it, though. I'm the one who can screw up and not lose weight. She's on a, you know, she eats the food we give her, so that's on us. That's on us. Yeah, I wanted to retain all of her mobility. She's a corgi. She needs to be very active, and I want her to be able to go up and down stairs because lately, as it's been warming up in Pennsylvania, in Philadelphia, I should say. I'm in Philadelphia. I'm in Philadelphia. That's where I am. Welcome to Philly. I'm in Philly. Okay. As it's warming up here in the suburb, I mean Philadelphia. She's been coming down here to hang out. Yesterday, she was sitting in front of the fan, like directly in front of my floor fan, which fills me with a little bit of trepidation. I've kind of taught her to not get close to the front of the fan, and if push comes to shove, I'll put a block of wood right up there, because she will, if unchecked, she was almost putting her head up against the fan grill. She is a Welsh dog. She needs to have cold and like rain to be happy, to be in that Welsh atmosphere. So she's got two like winter coats on. Oh, I gotta fix this thing for Krieger. That's his EV charger. But anyway, she was sitting right in front of this fan, and yeah, it's like, okay, I think it's warm out if the corgi is fan basking. I told her she was a good dog, and she did that like dog swallowing thing, the like smacking lips thing when they're like super content. That was a nice moment. I had a nice moment. She's a good corgi. She hasn't been on stream lately, which is annoying. I really want her to be on stream more, because people like to look at corgis more than they like to look at like weird thumb-shaped bearded glasses guys on the internet. There's a few too many of us, to be honest. At least I've got my niche where I don't have to sit here and like be angry at Disney for some reason. Instead, I can sit here and be angry at circuits, which is a little bit less populated. You know, there's a little bit more room to breathe. Our proverbial goldfish can expand to fruition. And then I can have dog shit opinions about electronics instead of other stuff that bearded white guys have opinions on. The internet is very tiring, isn't it? All right, soldering iron is tucked away. We got our front panel. I hope I'm able to make front panels soon. I've been thinking about that printer project, and I think it's going to be a lot more project than I give it credit for. We got to do like a full engineering on it, though. I need to park the printer on the desk, and we need to like partially take it apart and figure out what the sequence of events is and like time it. I may have to put it on the oscilloscope and get actual like precise timings for triggers that end up happening in the process of printing. So there's going to be things in there like little switches that'll detect paper and stuff like that. I need to get the timing down of those switches. So if we get multiple systems on the scope, oh, that's going to be a tough one. It'll be fun though, characterizing a printer like that. And once we have all that data, I will then be able to program a microcontroller to fool it into thinking that it's printing fine. At which point we can chop it up and make a linear bed do the same thing, you know, move in the same way that the printer bed moves. It's possible that we could also fool it, because the stepper motor might not be able to jerk the way the paper does. So it might be something where I have to fool like an encoder in order to match the speed of the printer going through. Oh, that's going to be so weird and cool, because the ways we can fail are just infinite. They're fractal failure here on Oh Bother. Wait, why didn't you turn on? Why are you off? GVM light? This is something we need to hack. This has an ESP8266 in it that controls the main microcontroller that controls the light. And so if we can get the ESP8266 speaking digitally, I've got in my notebook over there, I've got all the notes on how exactly to get this thing to change its brightness and intensity. It's not a difficult thing. We just haven't done it. And that way I could free up one of my other Tasmota switches, and this thing would just be a native device that would just be powered at all times, which I don't know if that's more or less efficient than an actual Tasmota device. I guess the ESP is pretty light, but it would be technically on at all times. Unplug the plug, plug the plug. Give it a second to get up on my network. Oh yeah, I do have a headache. Why do I have a headache? I think it has to be the little wound I have on the side of my head, because it's like this little tiny pain point just right there, and it just like, it's constant, and so it gives me a headache. Oh, it sucks. I'm gonna shoot caffeine at it, and hopefully it'll get rid of the headache. It won't. I have a project that FK would probably like, is a lamp that I want to make, a hanging lamp out of, oh, I don't have it here. I have these extrusions that have, ouch, what happened? Oh, it's a reoccurring like cyst. I don't know if maybe like I fell over as a kid and there's like a piece of wood in there from the 1980s. But it like a little like pimple forms every now and then in just about the same spot. I got a couple of those on my head, but I end up picking them because I can't be helped. I am a gorilla brain. Well, anyway, yeah. But so the lamp project, I've got these aluminum extrusions with an acrylic, like a diffused acrylic like strip in it, and they're really cool looking. They're real cyber looking lights. I want to put RGB LED strips down it. The RGB LED strips aren't very dense though. If I can get them a little bit more dense, then I can hang them. I want to hang them with a minimal amount of hangers and get that whole signal into them. I don't want to have wires that are zip tied to other wires. And then if I hang a bunch of them, I can maybe coordinate them in order to look cool. Who knows? But I thought that would be a really cool project. And not just like flat. I mean, like they're long bars, so I could do something like, you know, do like one of those things, and do like that, and do like a couple bars, and it follows kind of a curve, kind of like one of those. Okay, anyway, this thing should turn on. It does. All right, cool. Back in business. Corporate lobby artwork, yeah, but I mean, you know, the LEDs will look cool. It is very much like what I was thinking is like the Deus Ex, the first remake, Human Revolution, is that the one? Kind of look to it, but it won't be able to do the warm lights if it's RGB. I do also have warm white LED strip, but yeah, it'll be very uncontroversial and slightly pleasing to the eye, but not pop out too much. Corporate. Welcome to corporate. Hey, thank you for following. One person. It's always nice. We're doing a bit of reverse engineering today, and we're doing it in a bit of a weird way. I'm gonna make sure my title is up. Did I change the title? I did. Okay, good. I did. Yeah, we're gonna be doing a little bit with GIMP today, which is just absolutely astounding. That these projects to make like a free, I'm gonna make an alternative to Photoshop. What should I call it? What should I call my alternative to Photoshop? Maybe it should have like a punchy name, like something that like tells you what it does. You know, kind of like Photoshop does. Photoshop does the tasks of a Photoshop. So maybe I'll call my image manipulation program GIMP, because you tie it up in the basement and smack it with a whip. Look, what the hell? Who's naming these things? Why do they do this? I gotta talk about this on stream. I guess it's entertaining enough. If it had a boring name, it wouldn't be as entertaining to talk about. But it still means that like people turn on my stream at work, and they've got this guy who's going, GIMP. I said GIF for some reason. It's not a good look. It's not a good look. It's a Photoshop-like program. Yet another, yeah. Gag PBD. Captain Head says, I made the mistake of trying to look up how to use the mask tool in GIMP by Googling GIMP mask. It's just the worst. Why do we do this? I mean, you know, haha, programmers having their little hee-hee laugh, but then at the end of the day, I'm using this program to make like my summer car skins, and I want to show people how to do it, and I'm like, how to handle your GIMP. Like, back it up a few steps. back it up just maybe like a half step, maybe a full step. We change like one letter in that. I know it's catchy and it's 4 letters, but like, man. And they're all strong. I had this argument with somebody in high school. They wanted to make like a school newspaper website back when websites were like kind of new. And they wanted to give it like an acronym, and it had the weakest letters in the acronym, and they didn't understand why I was so adamant about this. Like DVT, that's like a really strong acronym. There's some combinations of acronyms that just don't, they're not good. They don't have like a strength to them. They're like weak. QLR, I don't know. Like, I guess QLR you could make stronger than that, but it was like, it was really weak sounding. I forget what it was. Like H is not necessarily going to be very good. HML. No, that's actually a good one. Damn it. There are some, I promise you that this is a thing. I promise you. I just don't have good examples because this is an argument from many, many years ago, I'll say, just to be nice to myself. Yeah, the flow of the acronym. It's just not, I don't know, some people don't understand. Some people don't understand it, and we have to somehow share oxygen with these people. Is this one going to be, whoa, okay, hold on. Microscope calibration setup, mic procedure. These are little algorithms that I put into the Stream Deck, and what these allow me to do is wait, why is this microphone only? Oh, I see, or microscope only, sorry. Yeah, the microscope is typically a multi thing. These little algorithms let me manipulate the Logitech camera settings, because there's some bug in the Logitech camera settings where things will be washed out and the thing will be automatically in autofocus until you flip the FPS back and forth, and then the camera settings will like lock in and you can manipulate stuff. OBS, it seems like OBS has worked in some kind of a workaround to that. I mean, the ultimate solution to this is for me to spend thousands of dollars on new cameras. Leb has sort of marked out a spreadsheet of Blackmagic products that would help me get there. I don't know if I really want to go with Blackmagic or not, but there are some slightly more professional webcams that I could go with that would probably retain their settings and probably look good, because you don't want to auto anything on these cameras, especially not Logitech. Logitech makes a wonderful camera. Like, I mean, you look at it right now, it looks great, but it takes a little bit to get there. You need to be able to get into the deep settings of the camera. I even got a camera app on my other computer that didn't get into the deep settings, and I didn't have time to get anything better until my doctor's appointment. So I sat there trying to manipulate some of the outer settings, and I couldn't change the resolution, the number of pixels, the stuff that I need to do in order to get the camera to work properly. So I had this doctor's appointment where I'm all washed out. It's not like the doctor did anything with their webcam either. They had some dog shit laptop webcam, so I'm looking at them like my face is on the table looking up at the doc, which I guess is kind of a typical doctor's appointment position, isn't it? But it's still weird, people trusting like laptop height webcams and no lighting at all. The Brio's right here. I have 2 Brios. The other Brio is in pieces. And yes, it does have the same issue from what I know. It's a little lesser so, but when we rebooted our whole system and I came back, it was in autofocus mode and stuff. It's got a better image sensor, but not by much. What the real meta would be, if I had space for it, would be to use the Microsoft Kinect, because they put a lot of effort into, Microsoft puts a lot of effort into some stuff sometimes, and they make really good products sometimes. They put a lot of effort in the image sensor of the Kinect. They wanted to make sure that their digital eye was able to see absolutely everything in the room, in spite of the fact that you might be playing video games in the dark. So they put a big lens on it for a webcam. It's not like this. It's a big lens for a webcam. It's a larger sensor, and it's much better at low light. That would be a really good camera to use if I was like a game streamer. That I'd probably use that. And then instead of having a VTuber model, you can pull up a 3-dimensional point cloud of your local area, like what the camera can see. So when we were testing it out, I had it on a tripod to the upper left. Actually, no, it was around where this webcam was. It was around where the face cam was, right? I put it on a tripod, it was like right here, but we got a view from like over there where there was no camera, where a camera could not exist. It was pretty cool. It was a very cool looking cybercam in rainbows. Do, 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 do. I don't know when we're going to get started. We have a lot of work to do. We didn't get a lot of work done on Dave's module yesterday because we had that giant raid. That was a lot of fun. You know, sometimes you don't get a lot done on these projects. And I actually feel bad about it because I need to get more done on things in general. I haven't been getting stuff done. There's been a lot of pressure from a lot of different directions lately, including the thing that I decided to do that I didn't have to, which is uploading my entire back catalog of streams onto YouTube. You know, sometimes those get pretty popular, not in my case, but in some people's cases they do. And a lot of that back catalog content ends up being able to generate any revenue at all, which mine doesn't. Every now and then I get a new user though, so that justifies all the work that I'm putting into it. That and the fact that maybe, just maybe, something like 300 years down the line, some AI is going to fuck up soldering something, and it's because of my streams. All of my content is going to dribble into the neurons of some kind of an advanced future AI, and it's going to end up soldering a fan together wrong, and it'll blow up, and then its memory will be erased, and that'll be the last remnants of me. But it'll be 300 years in the future, so it'll be pretty cyber and awesome. Oh wait, this is the song. Will I dream? What will happen to me? It's a DBZ abridged. Use this. This is the last moments of your life song. Goldo, that's who it was. I mean, this song is, you know, obviously famous for a lot of other reasons, but it is a nice meme-y sound to it. M-E-M-E-Y, not M-E. Well, actually, the original one was M-E-M-E, wasn't it? One transistor over there, a couple diodes. Oh, this is a cool remix. I like it. Here's your bop. Got me tapping my toes. Tippy, tippy, tap. Tap those toes. This is going to be pretty easy, this side of the board. The other side of the board is mostly planes with a couple connective traces. So this should not be a difficult job. And maybe we should get started just so we can get some progress in here. Because, yeah, there's been, you know, kind of want to get stuff done on this stream. It's hard, it's tough, because, you know, I have to talk about absolutely every single thing that I'm thinking about at any given point in time. You guys get an unprecedented view inside the brain of somebody whose brain is wrong. But as such, we don't get a lot done because I'm sitting here explaining and teaching as I go. If I were just doing this on my own, if I had the type of energy that I would have after stream, which there's not a lot of energy to go around after stream, let me tell you. If I had that kind of energy, and sometimes I do, we would be going over, like, these projects would be going a lot quicker. So just know that you guys are dragging me down, okay? Let's get started. What's going on? Father, what are you doing today? We're going to have a bit more of a cerebral day today. Let me get the music out of here first. Boop, 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 just in case this music is... Actually, typically it's blocked in Russia for some reason. They don't like you playing non-copyrighted music in Russia. Hi, welcome to Philadelphia. It is the middle of the afternoon. I am sitting here in front of my desk with a massive headache, simply caused by a pimple. I have a pimple on the side of my head, and for some reason it's like just an immediate trigger. There must be just like a line through my skull that goes straight to my, I don't know, frontal lobe. That's just giving me, like, it just, man, I hate it. Anyway, point is, we're going to do a bit more reverse engineering on Dave's module. We tried on Tuesday to get into it, but we didn't. Why? Well, there's a lot of distraction, and I'm kind of teaching you guys reverse engineering and sort of the processes behind it, and I decided to do a little bit of soldering because I had a chip come in that is supposedly one of the chips. Pop the pimple and your brain fluid leaks out. I wish. It feels like there's too much up here. Just pop my whole head like a pimple. But yeah, the point is, we didn't get a whole lot done. We had a huge raid of 200 people come in. Those are great. I love them to death. And the people who raid me, I hope you guys go check out their channel because they're always doing something kind of interesting. But what we are doing today is we're going to try a slightly different method of reverse engineering. We're going to try something that's a bit more visual, and it should be easier because we're actually taking our brains, our big squishy meat pie brains, out of the equation. We are going to be doing this on just simply a visual basis, and from that we should be able to get a schematic. We should be able to figure out what this thing does. We're going to use MS Paint, we're going to use GIMP. I am not going to do anything too crazy. Ow, I almost bit my tongue. And I guess, you know, you guys could just get exposed to a different type of reverse engineering. It's something that's very accessible, and it's something that we used to do all the time with IEDs. We would do this all the time because when something gets to a certain level of complexity and you're jotting down notes and you're figuring out what's connected to where, things get out of hand, and it just kind of cascades on you, and then all of a sudden you're overwhelmed by the amount of stuff that you've got to pull together. You're like, wait, I remember that I had to remember that node, but what is this node? And sometimes it just gets to you, right? Not everybody is a super ace at going through and figuring out all the connections to a node. So let's take a look. Let's get our initial data. Let's put that up into our image manipulation software, which for some reason these programs, these GNU, I guess, or what, any of these programmer projects, they always think of the most dog shit name they can possibly think of. So I'm going to be saying GIMP a lot today. There's going to be a lot of jokes in that direction. Just get ready for it. But anyway, let's get started. We need to get photos of the circuit board. For those of you that don't know, this is a 303, or rather a facsimile of a 303. The M303 was created by acidlabs.de, and it was designed to be a voltage-controlled oscillator with a filter. The thing about modular synthesizers, as seen here in the background there behind the spray paint can, modular synthesizers take what most synthesizers do, which is create audio and then filter the audio and sequence the audio, not in that order. Modular synthesizers take all those steps out apart from one another, unify the power supply, and allow you to connect things with headphone plugs. So you can connect whatever you want to something that sounds like a 303 and has a filter like a 303, and can create that cheesy, acidy house sound from the 90s. The thing about the 303, I've done a little bit of research. The thing is, the 303 itself, the original, is somewhat of a limited synthesizer. It's got a little bit of the sequencer in it, it's got a little bit of the synthesizer in it, but the sounds are coming from a DAC, a digital to analog converter. So the difference between this and an actual 303 is that an actual 303 is digitally recreating sounds. Now the 303 takes a cue from the 808, and the 808 is a legendary drum machine, drum sounds synth or something like that. I think my buddy used to have an 808. I think he used to have one of those. I really wish I still had it. He had a 505 too, which, I wish I had both of those. But again, they don't necessarily contain the original synthesis of the audio. They have digital processing in them. This M303 though is a modular synthesizer module. It would be a little bit over the top, although not these days, but back in the days when they made this, 2014, it would be a little bit expensive to put a brain in this thing and a whole DAC. Some modules do that, but this one instead decided to recreate the wibbling waveforms using transistors and techniques therein. That is unfortunate for us because that means that the circuit is a hell of a lot more complex and hard for us to troubleshoot. And without a schematic, I'm a little pressed for luck in terms of figuring out what the hell's going on. 303 and a 505, but a 404 is not found. Da-dum-bumps. Why don't you leave the jokes to me? All right, so anyway, we tried, what's up, Waycrash? We tried a little bit in reverse engineering this, and I've got some notes, but they're not very detailed. I don't have a whole hell of a lot going on here. What else do I have in this notebook? Yeah, this is my microphone project. Yeah, no, we don't have stuff that dates. What date is this from? I don't know. I'd have to carbon date this page. These were my notes. They're not very good. I talked a lot about how schematics are structured, and we looked at one output from the LM, not the LM13700, whatever the transistor cluster was, but I don't think that's correct. I don't think any of that is correct. So what we need to do is use a little bit of photo manipulation in order to put together the schematic for this device. You see, when my brain is involved, things go horribly wrong. So we're going to take my brain out of the equation, not out of my body, and we're going to take photos of both sides of these boards, and then we're going to stitch them together in an image manipulation program, and I'll show you guys how that technique goes down. It should be pretty cool, and hopefully we can ascertain. I mean, I can get a full schematic out of this thing. It's just going to be kind of a lot. At least we'll have a really good reference, and I'll start in on this now. Probably won't finish today, but we can get a lot done. So the first thing that I want to do is I want to make sure that this thing is sitting level, because parallax is really going to mess with us today. I have a microscope, and I have OBS running on the microscope, so I can take shots directly from that. What we would do in the past is we would take pictures of the circuit boards, and you would be kind of like off to one side, off the other. There was also a little bit of the fisheye of the lens would get in the way of things. We should be able to do a pretty good overlay on this. We're going to take multiple photos of each side of the board. I'm going to back the camera out a little bit too. Hopefully we can get good focus. Oh no, this is as far as we go. This is as tall as the camera gets. All right, very well then. And I'll mostly try to keep this straight up and down, and that should hopefully give us a nice straight-on photo of the circuit board. Hey, you move. Okay. So there's new puppies in the neighborhood, and they are super cute. They're miniature poodles. They're little chicken nuggets. They're so cute. We'll got to play with them a little bit, but she gets a little rough. So she basically like puts her paws down on top of the puppy, and the puppy just kind of like gives way. They don't have much of a choice though, because they're so tiny. And they're not going to grow that big either. I don't know. They're very cute though. There's a picture of them on the Discord. All right, let's get as much of the circuit board in here as possible. Let's get some light on this so that I can actually see what everything is. And let me straighten that out. It's going to take a couple screenshots for us to really see this to fruition. Oh my God, that's shaky. Actually, if I could get the whole top in a photo, that would be great. Nope, we don't have focus anymore. It doesn't focus anymore. Do this, do that. Oh, did I? Yeah, I did all my due diligence with the YouTube, right? Yeah, we're up on YouTube. Everything's going swimmingly. All right, cool. There's just nobody's talking. Wow, that is shaky. Okay, I gotta not bump the desk much. That is a variable amount of focus on this thing right now. Can we get slightly better image here? The problem is when I touch the microscope, everything shakes so much. All right, let's take, well, okay, I'm gonna make it straight up and down. We'll just follow the edges of the image. I'll do a right and a left side, and we'll stitch that together. It'll probably be, well, 4 or 6. I don't really know. So instead of, what can I do here? I can full screen this and take a shot, but I don't think I need that resolution. So I'm just going to use the snipping tool here, and I'll take my first shot. There. Oh, there's a blue box on it. I don't want the blue box when I'm doing Discord. When I'm doing OBS, if I highlight over the screen, the overlays are highlighted in like a blue box, and I don't want those in my final image. So there's that screenshot. We're going to go to this view over here. And I'm going to go to GIMP, which I already have open. No, I don't have it open because my shit crashed. Oh, no, because it was restarted. So GIMP, I'm using GIMP 2. I don't know if there's a newer GIMP or not. It's just whatever was available when I went to get image manipulation software. It's booting up right now. Come on, buddy. We're going to put the different slots of our top layer PCB in there and then line them up. So over here, I'm going to reduce the size of this thing so we can actually use it. There we go. We don't have a ton of room on the screen for this, but that should be good enough. Oh, we go all the way to there. There we go. That means chat can get a little bit of room to breathe. Okay, so new, file new. I have no idea what the ideal canvas size for this is going to be, but it's actually going to be quite a lot. I don't, well, okay, we'll just start with this size and just see where that goes. So I'm going to paste that in, give it a new layer, and so that's our beginning above the background. It's going to need to be a little bit larger than this, but we'll start with the different pictures of things. So I need the next photo, so I need to put up OBS. I just minimized it. And then we need to go to just the micro. So I get maximum resolution here. And let's take the other corner, which is just right over there. It's frustrating how close we are to getting the whole board in one image. The whole width of the board, that is. I'll probably be off by a little bit, but we can deal with it. We can deal with it. We're a little bit flexible. So next image. If we really wanted to get fancy with this, we could up the color contrast to an extreme degree, and that would allow us to just view traces and stuff. I've done that before to some effect on things that were difficult to observe, but these are pretty clear. I don't think we're going to need a whole lot. And then if I hit paste, it's just going to try to put it into the same layer. I need to give it a new layer, which is this button in the lower right. It's just the only way that I know how to do this. So those technically should overlay on top of one another just about here. So actually our width is fine. I think our height is going to have to be increased to the nth degree. Yeah, there's about what we have. So yeah, canvas size, and then height is 1080. Let's just make it like 3080. Where's the OK button? Is there not an OK button? Help, reset, resize. All right. We don't need the background. I'm just going to delete that layer. Go. The dreaded checkerboard pattern. Okay, so now we go back to the microscope and get another one. Am I going to copy the PCB? Nah. No, we're reverse engineering the circuit so that I can work with it. Because there are differences between this 303 and the actual 303 to the point where pulling up a schematic for a 303 is not going to give me an idea of how this circuit works. I need to figure out how this specific circuit works, and acidlab.de is not in the business of telling you how their circuits work. They are in the business of selling you a module, so they are under no obligation to share this with us. We have to get this information on our own, publicly, for everybody to see. I'm going to burp. That was the least satisfying burp I think I've ever had. There's a whole bunch of stomach acid right below it. Okay, so we need only micro. There we go. And now we need to move down to, I would say let's put these at the top of the screen, just like this. And that'll give us a pretty good distance there. Let's just get the edge of the board right there. There it is. Try to keep that straight. It's the fisheye properties of this camera are going to come into play here. We're going to have a little bit of trouble with that. So let's get, you know what? I think I should have more of the edge. We should edge it a little bit more. Come on, edge with me, chat. And that's not a straight line, but I can, well, I really don't want to move the camera at this point. So yeah, we'll go closer to the edge then. We'll just go like this. I'll move that up. Well, actually, those holes will be a good aligning tool. Overlap is okay. I just don't want to take too many pictures here because it's going to take us a little bit. Damn it, I got a blue box in there again. I can't show you because I'm literally taking a picture of my current, like I'm taking a picture of what I'm streaming right now. So it's like I can't show you me highlighting this with the snipping tool in Windows. All right, there's our other piece. So go here, paste that in. Didn't paste in because I don't have that focused. Try again, paste it in, new layer, and then that layer is going to go. That was the wrong, wait a minute. What's going on here? 1 and 2 and 3. This one, newest one. That's not the newest one. This one and this one. What's that one? That one's also the top. We have a duplicate layer. Are we running into the cut paste issue? No, we're not. Okay, well, there's something's a little weird. I think I cut and paste like the same thing in twice at some juncture. See, that one goes here-ish. One of these is a duplicate. We're just not going to worry about that right now. And then we need to get that area. That's a little weird. Wait, what's going on there? Those are at the top. Those are the midpoint. And then there's that header there. But it's not like there's staggered headers. What is this header doing? Oh, this is the pasted one. Oh, I see. Okay, so we don't need this. Oh, man, I confused myself very bigly there. What's up, Copper? Sound goes about here. What's up, Dowie? Not so easy. It has bias that connects to the other side of the vias. No. We'll be fine. This is the whole purpose of my showing off this technique. All right, so let's move over to where, oh, we need only micro. Sorry, you guys don't get to be on camera. We go all the way over here to this side with plenty of overlap, and I use the edge of the screen to align us. Plenty of overlap, because we're going to manipulate this into being nice and square. And then I use the snip tool. This is an alternative method of reverse engineering something. We need good photos. Oops, new one. We need good photos of the top and the bottom of the PCB. And I have to stitch them together because my best photo tool, the microscope, is limited in its field of view. Oh, Jesus. I just heard a big truck. And then a whole bunch of crashing noises because it's their cycling. I thought there was like a major accident like right nearby, but it was just them collecting recycling. Oh, look at the differences there. There's like different light on the traces. It's strange. I don't think much changed other than, well, the position of the board changed. So yeah, there's a little bit of a difference there. All right, so now we need to go midway of the connector. What's up, RYG? And show the bottom of the board, which I think we'll have space for, right? With the bottom of the board visible. Nope. Nope, not quite. Well, there's no other way to do that. I mean, that's the capacitor here. This is pretty much the line of the other photo. Yeah, I guess we can make that work. We'll make that work. It'll just barely fit, and it'll be kind of frustrating to align in the future. All right, so only microscope. The lens, the properties of the lenses that are distorting the image is going to come into play here. This isn't exactly a perfect orthographic view. A little bit of tilt in there. Get rid of the tilt. Everybody becomes a macro specialist when they start doing this kind of reverse engineering. I probably could have kept a little bit more room on the outer edges, just because that would have been. It's fine. We'll just work with what we have. We'll work with what we have. I probably also could have put down a big piece of aluminum as an alignment tool. Okay, so take a picture of this. Take a snip of this, a little snippy. And the blue box. I keep hovering over OBS, and it keeps putting a blue box on stuff. Some of you may have seen blue boxes on things that I take screenshots of. Oh, wait, no, there was a line in that. New one. Yep. Just inside of the... Oh, no, I messed it up again. Damn it. Okay, hold on. You guys just get to hear me complaining. This will get more interesting in a minute. I promise. All right. Go over here. Where is it? Oh. And then paste it in, give it a new layer, and put it roughly into position. Do we have enough room? Yeah, we have enough room. Let's move everybody towards the middle of the image. You see how close that's cutting it? That's the overlap right there. Oh, and the the reflection on the metal of the capacitor is different for the two images because it moved a little bit. I have a double active electric guitar, a stupid large single piece side PCB. Oh yeah, they love doing that. Guitar pedals are their own kind of, oh crap, their own sort of level of engineering. We tried to remake it because some of the traces lifted, and it just gave up because it got oddly complicated. Yeah, that's tough. Circuits will really kind of pull one over on you and suddenly become extremely complicated. Sometimes the number one rule with guitar pedals is just to make cool noises, right? I mean, the same thing can be said for synthesizer modules too, but at least they had some rules when it came to modular synthesizers. But anyway, the point is, like, guitar pedals, it's the Wild West. You could be faced with all kinds of weird stuff. Why does the chip get cut off? What's going on there? Are we supposed to be all the way over here? I think so. Or wait, what the, huh? Yeah, it's like this. And this there. Why does that chip still get cut off? Or am I missing? What is going on here? My brain is starting to hurt. It's starting to leak. My brain. Is there another chip on a grassy knoll? What's going on? How is that? Oh, because there's a... This is in the way. This one's in the way. This is a repeat of this one. Why is it even in there? Yeah, see what's going on is that was... That's supposed to be right about there. All right, we'll stitch them together in a minute. Oh yeah, I have a flatbed scanner, don't I? Well, it'll be kind of blurry when I do that because the height of the electronics is not going to be compatible with the flatbed. The flatbed's not going to quite be right. But I do have one. I forgot that I have one. Hey, Miguel Laz! Thank you for the 50 months. Holy crap. Nice photo work. Should consider working in front of cameras, too. I did this for 10 years, this kind of stuff. What's up, Miguel Laz? I repair laptops. Is that an acronym for something? It's impossible to do so. The PCB has 4 or 5 layers. Well, this isn't a laptop. Listen, I reverse engineered stuff like this for 10 years of my life. Yeah, multiple layers, blind internal layers are a scourge. A lot of the time they're going to be fairly simple. They're just going to be running power and stuff. But when you get that wonderful indicator that something is going on a layer that you can't see, it's time to give up. We would X-ray stuff like that sometimes. But yeah, the like internal vias, blind internal vias are like the worst. Man, this is your evening and you've chose to spend it here. Well, I appreciate you for it. You could sand off the top layer if you really felt like being destructive. Okay, so we're going to the left now. Beep, boop, beep, pop, pop. And we put this thing up at the corners of the screen. Just like that-ish. Yeah, photocopying this would be kind of nice, but... I'd remove every single part, catalog them, photocopy the board, return it all back to nature, set it off in the wild. Go, you're free, circuit. You no longer have any obligations here. I can throw it all back in the ocean where it came from. Boop. And then that one is going to go somewhere over here. I think we're still missing a... we have an upper right-hand photo, don't we? I think that this will be the last one. Yeah, one of the other ones just didn't get into the right spot. I think it's this one. Yeah, that one's supposed to be over here. Sort of makes up for this area. All right, so this is the top layer of the PCB. So let's get these all lined up and figure out what the heck is going on. I do need layer control, but I think what I'm going to do is I'm going to put it all the way over here just so we can see the image a little bit closer. But yeah, I am just going to simply be arranging these photos until they are all in alignment. Now, some things that can go wrong is that, you know, 1 or 2 pixels, things will be off by a tiny little factor. So they're not going to line up perfectly, but we don't need them to be perfect. We need them to just be close enough that I can figure out what's going on beneath them. We would often stress the need for really, really good photos in order to do reverse engineering, and we would get early 2000s flip phone pictures and still have to do our jobs. So yeah, just pixel by pixel, we can get this thing into alignment. You can see we've got just a little bit over the edge of the capacitor there, and to help us out, I can actually manipulate the, what is this? Oh, that's, okay, so this photo, I'm gonna need 4 times the detail. Please, Todd, no. Let's see. We're gonna need this one. I'm gonna need to get rid of that line on the top of it. And since our cuts are so rough, we can just do this. Oops, Control Z. I just deleted it from the layer that was selected, which is this upper layer. So what I need to do is select the one that I'm actually viewing, and then do just a little tiny cut off the top. A little bit of this. A little bit of that. Select none. Okay. Yeah, we're doing the Super Troopers thing. The CSI bother. I mean, if I really wanted to, I could throw a macro lens on and put this thing like 6 feet away and take a picture from like a huge distance away with a macro lens and try to get rid of any sort of the lens manipulation that's happening in it, but we don't need that. We're not trying to get a perfect representation of the circuit board. We're trying to be able to see where the traces are going. We're going to draw over top of it. That's the secret for today. If you already figured that out, you'll know. Oh, that was too far there. That looks pretty good. And then we can manipulate the opacity in order to see through what we're looking at. I don't know which layer we're moving right now, though. Oh, there we go. It flashes with it when you touch it. You can see how it twisted a little bit, which is going to cause some misalignment in other parts, but it's not that big of a deal. You can still see what connects where. That's the important part. What connects where? Go. Move over and just see what that looks like down the line. This is where, of course, it goes all south. It just goes completely south. But things are generally where they should be. Yeah. Okay. Good, good, good. Oh, you're still transparent. Bring that back to 100. See, like that V is off by quite a bit, but it doesn't matter. So moving down, that's okay. I'm okay with this. This one could probably move just a little bit. It might misalign things just a tiny bit down the line. Let's take a look over there. Oh yes, things are all over the place. That. Let's get them to line up. I got to reconcile which ones haven't been repositioned with the ones that have and are just off because the board is just a little bit crooked. Those will be fine. Those are a little jarring, though. Why are we still transparent? Who's still transparent here? You are. Get back here. Go. Yeah, like if I line this up, then other stuff is going to suddenly be completely off on the other end of the image. Like that. Oh, there should be a 5 in there. There's almost a gap for some of this. It's just parallax is totally different on some sides of this thing. So we'll get it close enough that we can use it as an observational trace layout. And that's going to be our top layer. We don't need to get it perfect. Lord knows that I could sit here all day and futz with this thing until it's all perfect. And I could use rotation tools and stuff like that in order to get it to be perfect, but I don't need it to be perfect. So there's one layer of the PCB. Let's crash all these layers into one another. You know, a lot of what I did as a career was under a time limit. So you don't want to spend too much time getting everything to be totally perfect if you're not going to use that photo anywhere else except for your own personal notes on how the schematic goes together. So as long as those traces are there, as long as the vias are roughly in the right locations, this design is simple and spaced out enough that we can do a very good job reverse engineering it with this technique if we don't spend 10,000 hours being a perfectionist, which is, you know, this is more me talking to myself than all of you guys. This is me talking to myself. Now this is going to be zoomed in a little bit. I think this stands flat on its own. Okay, so we'll have just about the same distance on this, which is good. I don't know what the orientation is going to be. We're going to keep it wherever it landed. I just threw it on the desk. So as long as we get it roughly the same, I think we should be in good shape. And then we go over to this. I'm using OBS. I'm using screenshots of OBS to do this. This side I could not scan. This side has headers on it. Both sides have big headers on it. And so those headers are going to make the entire image look like ass. And I'm not into ass. Let's see. Micro. I could desolder the headers and try to scan it, but I don't think that's going to benefit anybody. It's just not going to... The scanner is designed to get pretty good images of things that are directly in front of it, not things that are spaced off by whatever the distance of a header is. Anyway, the point is, by the time I get the scanner set up and do the scan, I would have been done the image manipulation technique. So there's no point. This is the one with the pretentious smiley face on it. So we're going to put that one in here. Oh, this is not focused. Hold on. And then give it a layer, which is a button down here that, you know, I'm sure there's a way to manipulate this program using keyboard shortcuts, but I don't know it. I do not know it. Hello, I am watching from Bangladesh. Hey, that's pretty cool. Welcome to the stream. I'm glad, you know, some YouTube people are filtering in, because I specifically decided to start doing a little bit. See, this is why this here is why I would feel more comfortable if I took the photos from a little bit further to the side. But I'm using the sides of the screen in order to align it. So, oh, we don't need the microscope view up here. We can get rid of that. Well, no, I can keep it for now. Eventually we're going to stop working with. Now we'll look at the desk. Actually, what that should be is the picture of. I know what that should be. Okay, hold on. Sorry, welcome. I'm your gibbering host. I've had too much caffeine already. That's not the overlay I wanted. We want the, where is it? It's right there. Microscope away. And then I want to get this one in, because that's the other view. And we can then move this over here. Let's make it a little smaller. Actually, I'll take this and chop it. There we go. That's just stuff this is another part of my shop. Okay, so only the microscope view. Where is that? Only micro. Burp. And then we move it over to the other side here. I can give it a little bit of space on the outside there. All right, and then I take a screenshot of my computer. This isn't exactly, if this was a camera job, then I would actually be using a camera, and I could take a picture of the whole board. We could skip this whole initial step of lining things the way they are. But now that I've started, I've got to finish it with the same equipment. I understand, Bird. I understand that you have to make every noise possible to you, but could you not make distracting noises right now, Bird? All right, so there's that one. And now we move down on the microscope. And I go all the way to the bottom. Wait, do I go all the way to the bottom? Or what did I do before? Did I do 3? Yeah, I did 3. So I need to put these guys at the top of the image. I'll put the 6 holes there, just right like that. It's like 9 holes, but whatever, shut up. Right at the top of the image, because the open vias like that, those will show through when I use transparency to view through the layers. They'll show through a little bit better than something like a normal via like that. Oh my God, motion at the front door. The front gate is fallen. There are enemies within. All right, so take a big screenshot of that. And take that over to GIMP. I'm using GIMP. It's free. All you have to do is suffer through the indignity of a program called GIMP. Why did it not paste? There it is. That goes just about here. Like that. We'll fix it in a minute. Don't backseat me on this stream. You guys are in my wheelhouse. GIMP works a little different than Photoshop, and you kind of got to learn it the way you learned Photoshop. It works a little bit different, and you just get used to it. It's like any old CAD program, right? You always feel like you're all thumbs when you use a different CAD program, and that's what GIMP does. It does the same thing. Everything works just a little bit different, legally distinct from Photoshop. Yeah, it's no matter what CAD program you use, no matter what image manipulation program you use, you're gonna have to deal with some just awfulness. But it's like, at least from the perspective of an engineer, you have to be kind of a jack of all trades. And if they want you to use a particular program, well, there you go. You got to use it. So it's just one of those things. You just got to live with it. But GIMP in particular took me a little bit to get used to. It took a little bit of getting used to. And I always love that meme where the guy's sitting in class and it's like, open Photoshop and make a circle. Like, use the shape tool to make a circle. And the person running GIMP is like exploding. Let's see. It's all hyper exaggerated. Damn it. Put the cursor on the screen again. Yep. Photo that. Bring that one in. We got 2 more to go. And then we'll do all the alignment, and then I'll show you guys what we're doing with this. Doot. And this one goes just about here. Where exactly? Oh, right about there. Yeah, unfortunately, I mean, I guess I could have taken the photos from a little further away. I could have moved it a little bit more because they're all overlapping. We've just got this tiny little area over here. How do I make a circle in GIMP? You have to do circle select. You have to fill that in with a pen because there aren't basic shape tools in GIMP. Next. Up to there. Don't have a lot to go on. I want to give it as much area as possible, and that way I'll have, because I remember this is kind of a stretch, this one down here. So that is going to be crooked. I may have to do a little bit of rotating. Rotating gets rid of a lot of your pixels, though, because everything is suddenly shifted to the side, and we don't have a ton of pixels to start with. This is not exactly high-resolution scans. If we did super high-resolution, I mean, yeah, you could do every manner of super high-resolution scan on your circuit board in order to use this method. And more power to you. I just don't feel like killing all of those electrons in the process of this thing processing it. There's a project that made GIMP as close to Photoshop as possible. It's pretty cool. Well, but then Photoshop added all of these wonderful, wonderful types of like features that followed what people were doing with their software anyway, and that's cutting stuff out. And so they added like an AI cutout tool and stuff. It looks really, really fun to use. It looks like it's very easy to use, and you can do a lot of really cool manipulation with it. But I'm stuck here with this program, and limping along like I'm cool or something. Making thumbnails with this barely functional piece of freeware. Wait, is it freeware? What's the license on GIMP? It's a GNU, right? Only micro. Get all you guys out of there. I'm not being as particular about positioning this thing at a right angle, and I really probably should have put something heavy on the desk that I could have aligned it with. Non-commercial FOSS. Technically, I'm using it commercially right now, aren't I? I'm kind of using it right now to attract followers to my stream where they pay me money to do stupid stuff. Is the most cynical way that I can think of it, but it's also true. Can I use it for criminal enterprises? Is that allowed? Screw commercial. I want to use it for criminal. Okay, cool. So now we got all those layers. Let's try to align them properly, and then we can start really doing some manipulation here. I'm going to move the camera away, and then we don't need the circuit out anymore because we've got all of our screenshots of it. Yeah, standalone Photoshop license would be nice. I'm going to move this out of the way so we have more surface area for the image itself. Everything is a little bit cramped because of my vanity and having chat and stuff. I could always do one of those streams where I'm a little dude in the corner that's cut out from the background. But I think as much as anywhere else, like, I'm not the main character here. It's all the stuff in the background. This is like my co-host. People are like, whoa, look at your shop. So in that vein, I would love to add a shelf, maybe like up there, up behind me, like maybe a shelf to put equipment on. It'd be nice if I had more equipment on screen. I need to go fully vertical with this shop because I don't have space for all my stuff. The only problem is the only way that I can reconfigure the shop is by getting everything out and putting it all back in. So maybe at some point I'll take like a couple months off and do like a full reconfigure. I'm almost, oh, what the hell is that view? I am almost jealous of Milton T. Pike's flood. He had a flood in his studio, and it gave him the opportunity to totally retool his whole thing. And I think he's getting close to coming back. It's going to be kind of cool when he returns. We'll move all the furniture so he's not really familiar with the place. He didn't really know who I was. I was not on his radar, which is unfortunate because Milton's cool. I like his streams. They're very fun. He's got a lot of energy compared to what we do here. So pixel perfect is not really our goal here, but we are trying to get it close enough that I can figure out what's going on with the circuit. As long as we don't try to sell the code. Well, we're not selling GIMP's code, so I guess that puts us in good standing. Could I sell GIMP's code? Make a tidy little profit. I sound like I'm Ferengi. Let's see here. Good positions for everybody. Everybody on the left side here is all in alignment, which means that over here there's going to be nothing but chaos and death. That's not too bad. That's actually not terrible. We kind of dead reckon that a little bit. Yeah, it's a little sloppy over there, but that's not a big deal. That's not a huge deal. Well, what's going on with the circuit there? It's disgusting. I'm gonna declare this near enough as makes no difference, although I'll move that over just a little bit. And maybe that'll give us just a little bit more sanity here. Not much, a little bit. Where are the little half pieces? They're all the way over here, right? Yeah. Chat is unfortunately behind the program right now. $10 a USB. Wait, what? For what? Wait, which program are we talking about? We're not talking about GIMP, are we? Have they? I mean, you could donate to GIMP, which I probably should at this point. All I know is that I look up the program and I download it and install it, and now I know how to use it. And if I have to use a different image manipulation program, it's going to be like square dancing with 2 left feet. What a oh, I see. If I to sell GIMP's code on the underground, yeah, I would sell it $10 a USB stick. Sorry, if you don't give me context, sometimes I can't figure out what the hell I said 5 minutes ago. It's on me, but okay. So now we have 2 layers of this PCB roughly associated with one another. If I took these with one camera, there would be a tendency for things to be a little bit fisheye. Just because of all the lenses. KiCad gives you a t-shirt for donating. That'd be an interesting t-shirt to have if I was wearing t-shirts. I'm too fat for those. Okay. Too professional for those? I wonder what GIMP gives. A hearty thumbs up, I would guess. So, if I view this, we can see that we are actually not oriented correctly to line it up with the PCB. Our pin headers are unfortunately on the exact opposite side. So, given that this is an image manipulation program, I of course have transform tools. So, we will take this inconsequential lower layer and we will transform it and we will flip it. That's it. And if I really was at odds with getting this thing manipulated properly, I could mess with the color, like the color, whatever it is, the not hue chroma, but like the curves, the color curves, and I could get it so that things are more highlighted or less highlighted or whatever, right? I could turn this into almost a black and white image if I really manipulated these curves properly. Or I could make it look cool and bluish. But yeah, that can reveal some stuff about your image if you can't quite see something, or if like it's too dark, too grainy, or something like that. You can mess with those color curves and sometimes bring out stuff that'll help you manipulate the circuit board. There have been times where you can't tell in a photo if it's a trace or not, or if it's like a bad etching, or what's going on with this PCB. You mess with those color curves and it'll highlight stuff for you. It's a simple highlighting tool. What we can do is we can take this whole layer, we can transform it, and we can flip it horizontally. Ta-da! So now all the text is confusing, but when we view the image beneath it and set this thing to a low transparency, and of course you can also high contrast that, but you can see what's going on the other layer of the board. You can see that a trace is coming in here, and it is hopping to the other layer of the board, and then it's coming out over there. This is what we try to accomplish when we are sitting here following traces. But unfortunate for us, very unfortunately for us, what we have to do is flip the board around. And I often put a finger on the via, flip it over, look at where my finger's pointing, look where my hand was, letting the days go by. You may find yourself living in a shotgun shop. Yeah, and that's tough to do. Sometimes the vias have enough space in it you can poke a pin tool through. These, I haven't run into those in a long time though. But yeah, the photo manipulation allows us just to X-ray the whole board. It's much better. Yeah, counting holes. You go, okay, so there's a cluster that looks like this. I'm looking for the reverse of that, which is going to be a ramp coming up this way, and it is the second to the top of the ramp. There it is. That's the one. And then you follow that to that. Okay, this one is the first one that we hit from that side, and so it's that one, right? Nope, it's the one below it. And then it's really confusing. This is why I actually really like surface mount technology, because you don't have to do the constant flipping in order to figure out where you are. The surface mount of this size is the most human reworkable that I think small designs can be. You can go a size up in surface mount, but that's like baby mode. I was considering whether or not I wanted to do a 6-channel mixer for a friend of mine and make it out of this size technology, because apparently in the field they need to do certain types of fixes a lot, and having Radio Shack sourceable components is a big deal, which you can't really promise anymore because you can't find a Radio Shack anymore. With Micro Center, I don't think they have surface mount, so you might as well jump into this technology, but keep it workable, keep it hand reworkable. But anyway, now we have all the information we need in order to reverse this board. We do have another board, but we can figure that one out at a later date. This is going to be a lot of work. We've got a lot of work to do now. And what we can do is start a new layer. Dun, dun, dun. New layer. So sometimes I would go multiple new layers, but 1206 baby mode, man, you got to work your way up a little bit. You don't need to be in the 1206 lane. That's a dumb place to be. Don't be dumb. You're dumb. It's like directly insult one of my viewers just for liking things to be a bit larger. So I have a new layer and I have a pencil tool. Easily swap in out cards for each channel and strip. That's what the mixer originally was, that 6-channel mixer, but it also used through-hole components so that if something broke, you could go to a local Radio Shack. You didn't have to bring a whole second mixer as your backup. What we'll do is we'll go through this component by component and we will highlight what all the stuff is. The view is going to be completely prohibitive and confusing, but when we strip away the backing, we will be left with a schematic, essentially, that we'll have to then rearrange into position. So I want a small pencil for this because, well, I'm not the smallest. I want a slightly girthy pencil. I want to be able to actually just highlight over these traces, and we will use a nice bold, what do you guys like? What color should I do on this? As if I'm going to listen to you guys. I mean, red would probably be pretty good for this. A nice girthy red. That's going to pop out from the green pretty hard, though, so we could maybe do blue. Blue's going to pop out, too, unless I shade it down a little bit. Burnt orange, maybe a little bit of a orange, or a purple orange, or a red orange. Let's go with a little burning on that. There we go. Nice jack-o'-lantern. All right, so now I just start highlighting my traces here. This is actually a mess. What the hell's going on in this area? Oh, there's a via under the chip. That's cool. That's kind of cool. It's going to be tough to reconcile the multi-layer stuff, but when we deconstruct this, it'll come back together. We need to get components in locations for this. So I'm actually going to do a smaller than this. Problem I have with GIMP is how these arrows work. When you do like small pixel sizes, they're kind of not cut out for that. Like 2 pixels is going to be, that's pretty good. Okay, so I mean, we should start with power, but I'm going to start with some of the more interesting parts of the circuit then. So yeah, we have like nothing. Was there supposed to be something there? See, that looks like it's connected, but I don't think it is. That's why we go back to the microscope for some stuff. That really looks like it's connected. I'm going to hit it with the pin tool and see if whatever that is pops out. Oh yeah, it's just dirt. Okay. Okay, so this is a non-component, but we can just put it in as a question mark, I guess. We'll just go, I'll just put the pads down. And we'll do a question mark there. And then go down here, and we have a diode, and so we can just draw the diode directly over the component. Over here, we got a resistor. Should I do box resistors? I should probably do box resistors. That'll probably look a little bit better. Of course, there are no basic shape tools included with GIMP. We're using GIMP simply because it's a multi-layer photo image. I can't use Paint like I do GIMP. So I will still be hand drawing everything because that's just the style of my show. But yeah, we'll do boxes for resistors. We're not above that. Might as well put a dot in there just so it's clear. There's going to be a lot of overlap here because this is an actual board instead of a schematic drawing. We are turning it into a schematic drawing. There were discussions about using AI to do this at some point in my old job. So I just keep drawing like this until I'm done the whole board. It is monotonous. Now I could actually do the traces on the other side of the board on a different image. I could do a different layer. We got plenty of layers. My summer car image like this was huge. It had layer categories instead of just different layers. And then we had a program where you could actually import an image. It would be interesting to try to use Fusion 360 in that manner. Because I think, well, you can import a canvas, but I don't know if Fusion 360 allows you to do that in its schematic program. I don't know if that's possible. I mean, it would be a style of auto routing. We don't know where it goes under there, and I don't know if it necessarily meets up with this trace. I think it goes somewhere else, and we can use the multimeter in order to figure that out. Yeah, this probably could be done in AI. If you identify what the chips are, AI would not know the chips, but there was talk about making it an AI thing, and it probably could be done pretty easily. I'm doing it by hand because I'm not an AI. I mean, I could also do image manipulation in order to do this at first pass too, but getting it into like Eagle directly would be kind of neat. But I think they've already cracked that egg. They've probably been working on this for the 5 to 10 years that I've not been doing this job. So they've had plenty of time. Hopefully they've utilized it correctly. Then again, they got rid of a lot of the engineers, so who knows? Maybe they don't have the resources for such things. This one's going to be tricky because I'm going to actually have to draw a bunch of transistors inside of it so we can see what the individual transistors are doing. What is that? I'm going to call that a capacitor. I think it's probably big capacitor, but it's gray. It might even be a coil. I don't know if that'll be useful or not. I think it is a cap. I think these are caps. Yeah, double checking it would be pretty important. I don't know if I totally trust AI. This is a TL072. Oops, I wanted the microscope. We know this is a TL072. There it is. TL072C. So TL072. I mean, with the way language model AIs work nowadays, you wouldn't just need it to figure out where the traces go. You could also have it rearrange the schematic to be readable. It could follow all the rules that I typically follow. TL072. Low noise. FET thingy-majig. So we need to see what's inside of the chip. I hate this data sheet. This is just not a great data sheet. TL071X, TL072X. We have TL072C. 72XD, DDF, J, blah, 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 blah. Plus, minus, 8 and 4. I'll just put a plus and a minus. Actually, I'll do an up and a down arrow. Well, can I fit the up arrow in this? I don't know. I'll just do this. Up. This one will go down to ground. And then on these pins, I have VCC plus. This is the output from 2. So we have this is a difficult color to see on the background of everything else. I probably should have gone a little lighter than this. That's fine, whatever. I'll do an op amp, and then we'll do this. It's gonna be a little bit greasy at first. This one is minus and plus. I don't know, I don't have room to mark it on the symbol that I drew. Minus and then plus, there. And then these just connect to one another. There's another connection there. And then on this side, we have, what do we have? Pin 1 is the out. So we've got this going up like this. Is that actually where the out is? Wait a minute. 2 out is right next to plus. Yeah, 2 out here. And then this one's 1 out. That's weird. I guess it's unity gain, but where's it going to? We don't know. There might be something going on the other side of the board. So let's see. On this one, we have... Oh, this is the minus input. Okay, okay. No, pin 1 is... Okay, so that's like this. Shit. This one's minus. This one's plus. Plus goes out to here. Minus goes to here. It can be a little bit sloppy. That's okay. And then we go down and out here. So I got to keep tracing this thing. My shoulder itches. Hold on. Why does my shoulder itch? It's the glucose sensor pad is over 10 days old. So feed it Mauser's database, and it might be able to route it and take parts into consideration. How much are you going to trust that, though? Then a few schematic programs just go based on lowest distance. There's what's called topor routing, and topor routing is kind of hilarious because it's as the bird flies. It just goes minimum distance, and then it does minimum distance, and then the next trace that gets the next minimum distance goes, and then the next one from there, and then the next one from there. And it ends up making boards that are utterly cursed looking. We've gone over topor routing on the stream before, and it's horrific. And I wish I could get a plugin to use it with Fusion, because that would be hilarious. Utterly hilarious. All right, come out of here. So basically what I'm doing is I'm just highlighting where all these traces are, and then we'll have this absolutely confusing drawing to sort of rearrange into structures that look like what they should. And I'll have to take power and ground and take the traces out and then just slowly manipulate it away until it looks like an actual schematic. Why would they not? No, I'm actually not sure about that. I mean, I've messed up before with this thing, so maybe we should take a look at that a little bit further. You are correct. TL072X. What are we? It was TLO72C. $29M, Texas Instruments. This one is the pin function TLO72. Oh, pin 1's over here. Wait a minute, I got it backwards. Yeah, it makes more sense that they would have unity feedback instead of the two ends tied up. So let's start that one over. Welcome to my Philadelphia accent. Over. Get some water. Okay, so pin 1's actually here because there's the stripe. I know this is hard to see. Copper chose the color. I've done the same horrible trace Photoshop thing. You usually make a layer for traces and one for components. I mean, maybe I should do that, but that would be a lot of flipping between layers. I could maybe cut and paste them into another layer if I really wanted to do that. I think just getting the data down first is the most important thing. So I'll do another layer for the bottom layer of the board, and that'll help us with it. Code Rush, what's up? So Code Rush, what we're doing today is we are reverse engineering this 303 PCB from acidlabs.de. And what we've done is we've taken a bunch of pictures with the microscope, because it's the best camera that I have, and we've overlaid one side of the board on top of the other. And then we are taking that and we are tracing over what all the components are so that I can figure out what's going on with this thing. So we've got one of the layers mirrored, and then the other one is sitting beneath it. And then we can tell where the vias are connecting loosely based off of the two different layers of PCB. So this is one of those reverse engineering techniques that I seldom find use for, but it is very nice to be able to take your stupid brain out of the equation and actually be able to ascertain what the schematic is doing. So inside of the chips, we draw the functionality of the chip, unless it's like a microcontroller or something like that. I've heard there's a program that actually allows you to do this, but actually converts it to a schematic at the end. I forget. We used to use, at my old job, we used to use a schematic program where you could take an image into the thing and overlay the components on top of it. Oftentimes that was a little bit useless to do. I think I did it once in the 10 years that I worked there. And it was, I mean, it's like kind of useful. You get them all in there, but then it becomes kind of a spider web nest situation. It's better to take that image and then copy it down to something else, right? I'm going to be probably using MS Paint just because I don't have a good schematic manipulation program. And if I used Fusion 360, that would be a little bit too much like building my own. And I don't really want to build my own. So pin 1's over here, which means that pin 1 is up top there. So then this is going to be the output. This one will be the positive. And this one is the inverting input. I know that's hard to see because the chip is black, but whatever. We'll just keep, I'm going to keep using this color. So then that makes this one the output. This one is minus, and this one is plus, which makes this a non-inverting configuration, right? Or a unity feedback. Jeez. Okay, so that means that actually this is a little easier to draw because this is the one that is going to ground. Whoa! That was the one key. What did that do? Select none. GIMP is a little tricky to use sometimes. So that one goes to ground. And actually, I'm going to put this inside of a box. 072. And let's see, this one goes to power. My power symbol is an arrow. My ground symbol is an arrow, a hollow arrow. So an arrow with two things on it and then a hollow arrow. That's just how I learned to do it. It's not even how I learned to do it. It's just a standard that I used for a long time and got very, very used to because they are distinct from one another. If your grounds are anything but shared, and like if you have a different type of ground or if you have a different type of power on your board, then you'll want to mark it next to the symbol. And some people use different symbols. They use like circles and squares and stuff like that. I don't like to mess with that kind of stuff. I like to just use the same symbol for the whole thing. Select none. I'm sorry, I'm talking and doing stuff at the same time. So this one is power. So that can just be an up arrow. Power I do as an up arrow, ground I do as a down hollow arrow. That orientation remains static. That diode could be centered a little better, but we're not trying to make it pretty. We're just trying to get it all down on paper. Resistors we're doing as boxes just because the squiggly lines are going to get kind of annoying. Vias I'll just do as big circles. Okay with that. Box. So yeah, this is all we're doing. This is something that clearly an AI could do, but we're doing it by hand. Inside of this thing are a bunch of transistors, and that's kind of what I want to check over, is whether or not the circuit makes any sense from a perspective of transistors inside of this thing. Is that the right amount of pins? I guess it has to be. Over to a capacitor. Doot, doot. Over to here. And that connects to here, which is a resistor, which goes over to here. Also goes down here to another capacitor. So we just keep doing it like this. It's not the most glorious work in the world, but it will allow us to figure out what the hell this thing is doing. So this thing is a question mark. I'll just put a question mark here, draw the two pads, and a little thing like that. And this goes up. We'll do a dot. Well, I want to highlight the trace, so into a resistor. Now, if I were fully reverse engineering this, I could also jot down what the values for some of these are too. Oh yeah, that's pad, question mark, pad, over to there. We'll figure out where these go later. Here, all the way into the chip. This comes up from God knows where. Is this. We'll be able to sort of reckon what's going on under the chips eventually. My lines are so woobly. I got woobly lines all over this thing. But yeah, this is a simple process that just takes the brain out of the equation and allows us to look at what is going on schematically with the rest of the board. So there should be some revelations as to how the circuit is functioning once we get all this done. There's still a couple chips that have scratched out values on them. And if you really wanted to get fancy, you can use multiple different colors of pencil to highlight different traces, different functionality and stuff like that. You could really get fancy with that. But I'm doing it dead simple. I'm just jotting down what is here so that I can then come back and figure out how smartly I am in order to figure out what's going on in the circuit. Sorry, I'm hiccuping. I had half of a leftover Wawa hoagie. That was very small. These should probably be in a box. I'll just put them in a big header box. But the header box is going to look like crap because unlike MS Paint, I don't have a manipulation tool that does basic shapes. I don't know what the mutants that put together the GIMP program were thinking, but somewhere in their completely deformed brains, they decided having a tool to make a circle or a box was never going to be necessary in their environment. They just decided to make it instantly memeable by not giving you the functionality that you would like. Photoshop has shape tools. There's probably a plugin that you can install. There's always somebody's probably taken up that functionality gap. This is the worst header that I think I've ever drawn. All right, there's that header. There's trace coming here. Whoa. And that goes there. That's terrible. Okay, just like that. And then I don't know where it goes. It could be anywhere. These will look more clear when, you know, we actually get rid of the layer beneath it. And then my cave drawings will be properly visible. So that other component, well, we'll look at that. We'll look at that later. Oh, look at that. You can also do that layer with this one at full opacity. And I can see how these are connected. Ground, and that one goes over to this big trace that goes over there. And that's what that big guy is. That's a power. Those go under. This one pretty much seems to go to this pin here. I think that's safe to say. What is going on inside of this chip? Well, we know the identity of this chip thanks to our reverse engineering efforts. And so we know that that chip up there is a... I can't see it. Microscope. Microscope, saxoscope, stethoscope. Let's see. Oh my God, what was that? The 3700. I have it written down over here. LM13700. So we need to look up that component. LM13700. Dual operational transconductance, blah, 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 blah. Wait, that's not that. That's not what that is. That one's different. Did I put an LM13700? I don't think I put that in there. What is that part called with all of the, I don't know the part number written down. All right, we got to figure out what that part number is. Boop, boop, boop. Let's go to this one. Get real close. Or is this one actually the LM13700? Oh yeah, it is. Okay, so this is the transconductance whatever. LM13700. What is it called again? It's like it's a weird amplifier thingy. Dual operational transconduction amplifier with linear diodes and buffers. I'm very tempted to just cut and paste this thing into the just cut and paste the whole thing into the image. We can try it. We can see what that does. Take that and just pop it into here. It didn't even do anything. Paste. Give it its own layer. And then try to align it. First of all, spin. I hate how these are all separate tools. You don't have like a master transform tool. That. And then scale it. Unlocked scale. This is stupid. Well, whatever. Make it a little wider because the pins don't really necessarily need that. There we go. And then back up in opacity. I'll just sit that behind this layer. Sure, why not? We'll see whether or not this makes any sense. I wonder if I should just draw the stuff in here instead. But there's so little room to draw. Well, let's okay. Here's what I can do. I can go here, and then I can highlight this and delete all the traces that I drew in, and not limit myself to this little tiny area. I can just make all of the symbols here on this layer, and I can use a pencil. I'm gonna make this. Well, we can use this size. Okay, so in we go like that. I am not drawing those diodes on there. Plus, does that really cross over? I guess it does. MS Paint 101. This is a little bit more than MS Paint, though. This program is capable of a little bit more. Or still working within the bounds of the box that I drew. We draw the balls right there. Okay. And then Darlington's going to be tough. I'll try to draw that accurately. That's terrible. Strange Darlington. I don't know what these things do. The transconductance amplifier. Off into the board. Motion detected. Oh, that one's terrible. I mean, if I use a smaller pencil, that could be fine, but whatever. It's going to be hard to see. We'll just have to deal. Plus that, this one up and over, down, and then in you go, in you go. Wow, that was a lot. That's a lot to fit in that small of an area. A lot of stuff. And then one of these is power in. I don't know which one that is. Let's see. Go back to the data sheet. Specifically mentioned as the linearization diodes. Look, linearization or not, I'm not putting them in. So V minus is there, and then I'll put V plus is on that line. Oh, select none. V plus, V minus. All right, it's super shitty, but we can at least kind of see what's going on here to come back to later. I mean, so far, we've got something of a schematic going. We've got a soup going. And it'll all kind of come together as we keep going with this thing. And we can then start arranging structures into where they should be. Doing this fully in CAD, where you put like CAD symbols down over the image, it is one way to go, but it creates a lot of mess. So when you do reverse engineering like this, you draw it again, you draw it again, you draw it again, and it becomes less sloppy every time. So I don't need that anymore. I'm just going to delete that layer, and then we'll bring back in this, and we'll continue our shadowy work, our evil work. We are being evil and reverse engineering. This is unclear to me. We got to look at that with the microscope. So we are currently in the upper left corner, and there's just crud all over this board because of our soldering. This is where we would either ohm it out or, you know, just look at it a little closer. So I'm actually going to move this closer so we have a higher power magnification on the microscope. That'll clear things up as we get more pixels towards our problem. And we're upper here in this corner. Nobody puts my circuit in the corner. Yeah, so moving the flux around a little bit, we can see that that's not connected. Not connected. So this and this are connected though. So we can go ahead and do that. So that one and the one over here. What is that middle one doing? I do not know. And it doesn't go to V plus. V plus is over here. No, V minus is here. This one is the output for the transconductance amplifier. Do I have this upside down? Is this one of the ones that I have upside down? Yes. Damn it. I have to flip it 180 degrees. Pin 1 is here. Let's double check with the data sheet. Dumb. I always flip stuff. I don't know what's wrong with me. Yeah, pin 1 is supposed to be all the way down there, so we need to flip this around. So I think what I can do is I can use a freeform selection tool on it and flip it 180. So we're going to do the lasso tool. I'll just grab this roughly crooked the way that I have it in the picture. Oh, really? Really? What is this tool? Wait a minute. Oh yeah, there's, I mean, all this stuff. There's always going to be problems. And then I guess I double click or hit enter. There we go. Rotate. And like that. Let's move it up and over a little bit. Make sure it lines up. I can't tell what's going on. There we go. Just about there is where it lines up. Select none. Can I not select none? Oh, it's a floating selection. What the heck? At least this way I can kind of manipulate it into place. It's all fuzzy now because I've rotated it. I'm the same way. My V minuses and V pluses are upside down, but that's fine. All right, I'm just gonna merge that down. We'll just deal with it being sloppy and weird. That there, that goes there. This one goes here, out to there, out to there. I don't know where that one goes. This comes over from here. That's good. That's good-ish. They're close enough. And then, oh God, it's hard to see where that one's going. Oh, it goes nowhere, that's why. Yeah, V minus goes over to this capacitor, and then those, I'm going to assume, go to ground. Yep, that's a ground. So this just goes... Well, actually, shouldn't that be plus? Isn't that illegal? Isn't that immoral? This one says V minus, but it seems like, well, it depends on, that's true. We got minus and plus voltage on the board, so it's actually kind of unclear. So yeah, let's just do that, and let's just keep going. That goes to there. Don't know what that one's doing. I guess I don't have the microscope up on there. This one seems to come from there. I don't know why there's a part of a, what is that swirly Pokemon over there? This one. Yeah, we don't have to dwell on this for too long because we're going to analyze it later. We're not analyzing it right now. We're just marking down what's there so that we have a full sketch, very shitty sketch of what's going on. I'm going to assume that this is a transistor, and the fun part about transistors is that the symbol is that, right? So with a transistor, if you have a transistor that you're looking at, some of them are this shape. They're like a can with like a D shape on them, and it historically is like impossible to figure out which end you're looking at this from. You could be looking at it from here. You could be looking at it from here. You have something like a collector, a base, and an emitter. Now the symbol for a transistor is a flat block with a base. In this case, in this flavor of transistor, you have a C, you have a B, you have an emitter. The collector collects current, that's where the current sits. The base activates the transistor, and the emitter emits the electrical current from the outside, whatever, right? Like in terms of physics, a transistor is 3 pieces of silicon. You have 3 pieces of silicon, an N, a P, and an N. Now that's not too important. Well, it is in terms of how you're trying to switch it. Negative, positive, negative. You have one negatively doped, which means they've added chemicals to the silicon in order to make it conduct or not, positive or negative. One either has holes, the other has electrons. At the juncture between the two, because of the way charges work, you have a boundary charge condition. And that boundary charge condition pushes the opposite poles a little bit further into the silicon. And if you force the issue by adding current to one of the poles, well, the base, then that will allow current to flow down through the entire stack. And so you have an input, an output, and you have a base, right? So then it would stand to reason that if your physical device is shaped like this, then it should be arranged like the stack of silicon. Look at how similar those are. You would be wrong. Let's just quickly look up SMD NPN transistor. Collector, base, and emitter are not, in fact, arranged that way. Is this stream available as a VOD later? My damn brain requires sleep. It'll be on Twitch for 30 days, and it'll be in the streaming section of my VOD channel, which can be found here. For YouTube users, you might want to jump over to Twitch if you want that link, but it is on. What is this you're working on? This is an M303. It's a modular 303. But the people at Acid Labs scratched off some of the component values, and we've had to reverse engineer our way into knowing what they are. We still haven't been able to fix it. This is from my buddy Dave. Yeah, so we're doing some hardcore reverse engineering. I get to show you guys some of the wacky techniques that we do in order to do some hardcore reverse engineering. Yeah, it's automatically up on that channel, and YouTube won't delete it for now. So instead of collector, base, emitter, we have emitter, collector, base. So that means this goes like this goes here, this goes like that, over to there, and then that goes there. It is horrifying. Anyway, let's get rid of all this mess that I just made. My arrows are not part of the circuit, so I gotta delete all this stuff. Okay, select none. Let's get that board back in. And so we have, wait, what the hell is this symbol? I just noticed this. Emitter, oh, the B is cut off. They did a really bad cut job. It looks like it's emitter, emitter. Oh, geez. So the base is up top. This is the base up here. So I'm going to draw a transistor symbol. And then the emitter is here. I'm going to draw it as an NPN. It might be a PNP. The only important part about what I'm doing is that the symbol is there. We can argue about what it is once we see the context of it in the circuit. Something to distract me while I should be productive tomorrow. Tomorrow we're going to rip out the big book of circuits and try to do something simple. Unless I'm too engrossed in this thing and I need to really get it done. I'm just really sick of people saying to me that I should be working on Burn the Subs. I told Dave I'd fix his synthesizer. A man of my word. All right, moving on. Keep moving. So the point of what I'm doing right now is that it is brainless. All we have to do is draw over stuff. We're not under the gun to analyze anything or figure out what the circuit structure should look like, because everything is structured as it is on the board. It frees my brain up so that I can relax and my brain doesn't friggin' melt out of my ears. This is a big capacitor. This is a big one. And I don't know where this other thing is going. Let's look for a via on the other side of the board. No vias on the other side of the board. So my guess would be this goes here. These I'm going to draw as a box because I think these are dual transistors. But I'm going to draw it as a 6-pin box for now. And they're dual transistors. I'm guessing that they're matched. It looks as if They are used in some kind of a transistor ladder, which I believe is something that synthesizers do in some way, shape, or form. They're a little bit confusing, and maybe we need to do a little bit of research on them. But again, we're avoiding research, so. Because these look like transistors. This looks like a through-hole transistor right here. What's up, Mahalo? What's up, Hef? Cool shop of wonders. And it's more like broken stuff, but, you know, you do you. Are these really connected like this? I guess so. It just seems a little weird that they're like that. And are these coils or are these capacitors? I believe that they are capacitors. We're doing a method of reverse engineering that takes our brain out of the equation because I don't want to do the thinking right now. It's Thursday. On Friday, we're going to get out the big book of circuits, and we're going to try to do something simple because yesterday kind of phased me a little bit. We had like no confidence, and so I need to build up a little bit of confidence in our ability to manipulate and work with actual physical circuits. That's something that I would like to do. So tomorrow, we're going to work on the big book of circuits. We're going to find something real simple. Something oscillator related, though, because these are oscillators, and you know we want to stay in that subject. ECB is the Japanese standard for transistors, i.e. 2SC, oh, the 2N, 2SC, yeah, 2N3904s. And then actually the British are the BC is for British. It's Sunday before work on Monday. What's that? What's work? I don't know what that is. There, down like this. It's like this. I did this for 10 years of my life, not this specific technique. I used this specific technique a lot, but I used it in a different manipulation program. It might have been, it wasn't IrfanView. I forget what I used. No, you know what? I did use GIMP. I used it in GIMP. This very technique. Like this, over to here, goes there. Is that a willow coming downstairs? I hope my puppy decides to crash down here because it's very fun when she does. There's nothing underneath these, so what are they doing? Strange. We're going to have to find a part number on those and figure out what the hell they're doing. I'm going to guess that they're transistors, but they might not be. Oh no, I heard a dog walking upstairs. Is that a blind via? We got into this portion of the board. We got over here. What is that doing? Is that just like an artifact? This is a 2-layer board. There are not more than 2 layers. Typically, that symbol out in the open is, oh, okay, so maybe there was a different version of this one that had the flood-filled ground plane all over the top layer, and somebody put a via there in order to bring that to the top layer. But then they decided that the top layer wouldn't have the fill, probably because it was so sparse and it didn't really make much of a difference. So they decided to not go through with it. Usually I pepper vias like this all over a design. Oh, whoops, this layer. All right, let's see. Get the rest of this thing in here. That doesn't go anywhere? It doesn't go anywhere. Oh, but this does go somewhere. Okay, so that's where it's coming out of. This whole ladder, this transistor ladder filter of some type. So we will get that when we do the next layer. Down we go. What we'll probably end up doing is looking up stuff. Like look up things on like Mod Wiggler and things like that to see what these things look like when they're drawn and see if we can't draw them as they're supposed to be drawn and get an idea of what the circuit is doing. That is one of the primary things about reverse engineering is you are a vessel by which you are communicating to other engineers what the design is doing. So if there is a way that other engineers draw something, you draw it that way. And typically the way that things like the way these schematics come together is not exactly how you'd think. A lot of the time it's just how do I do this again? Okay, let me put this, and then let me do this into this. And there's not a hell of a lot of creativity going into some of the circuit design. You would think that they're these big, you know, pulsating brain, super smart engineers going, well, now I need this current to do this and this to do. No, they're saying I need one of these, one of these, one of these, one of these. Oh, there's a little bit of noise. Let me put a capacitor there. And I'd like to get to that level. I'm not quite at that level. This looks like ass. Hold on. A lot of this is not going to look great, but whatever. We're in GIMP. We don't have a square tool. Select none. Where's none? None. I should memorize that shortcut. Yesterday, I was doing Blender in order to try to put together that RC car body, and I discovered that every single thing in CAD is cursed. If I did like a hollow shell of the car body, it overwhelms the program and everything explodes. Should have used Inkscape. Inkscape is its own bag of squirmy worms that I just don't want to get on my hands. With the 3D manipulation, what I was able to do is make, so I started with a car body that was just an outer shell, and I need to make some kind of an inner shell. And you say, oh, you just copy it and shrink it and do all that stuff. Well, there's a lot of structures in there that I don't need. And so what I needed was what's called an alpha wrap. And an alpha wrap takes what's essentially a ball bearing, and it traces it over your three-dimensional design, and then it makes another shell out of that, right? And there's all kinds of different manipulation tools to shell something like that. Should have used a real CAD software. You should have been banned. I don't need to draw straight lines. We're fine. None of this needs to be up to code. But so I was able to make an alpha shell by shelling the one side, and it made what looked like a sponge inside of the 3D model. But then I had to go through vector by vector and delete stuff. Oh, using Blender. That's not quite as used. It's kind of weird. I don't know Blender very well, so there's probably tools that I could use, but I don't, you know, shelling the inside, that's tough. You need something like an alpha wrap so that all those features that are modeled on the outside of the car don't, like, I don't need a grill on the inside. I just need something smooth to create the inner, sort of like a skin wrap, but like a loose skin wrap. It can. We tried a lot of stuff. It was very difficult to do. See, everywhere they have one of these surface mount transistors, they have these 3 dots here, and these 3 dots are the pin layout of another, like a typical transistor. I don't even know if these are transistors, though. These could be diodes. You know, this is looking a hell of a lot like a diode ladder filter, if I'm honest. That might be a diode ladder filter. These might be diodes. I'll put them in as transistors, or maybe I should put them in as boxes, because we don't know, because there's 2 things being connected to each other. And on this one, it looks like it's just floating. There's probably a trace underneath it. So I'll put them in as boxes. I'll put them in as 3 lead boxes, and we'll come back and figure out what's, oh, it looks like that one probably goes like this. That seems to be what's going on. So this goes like this. That might, no, that wouldn't cross over. Yeah, and then nothing is going on beneath it. I'll put the other transistors in as boxes. Let me go correct my work on that one. Once I do this. All right. Ooh, that's a 0 ohm. Jot that down because it's just a short. There are no ohms. That's a big claim for the metal they used in there. I don't need no fancy CAD tools. I mean, I could probably, you know, the thing is, Fusion 360 allows me to import a canvas and work on top of the canvas, but I don't know if it'll allow me to do that within their schematic manipulation program. Then, on top of that, I have to have package types for everything that I put in, because it has to be associated. This is a design tool and not just a schematic notation tool. So I'm going to have a physical package and pin layout that is associated with everything on there. And I don't want to reverse engineer this on that level. I just need the knowledge of what is here in order to be able to... Now, which way is this? This is... The line goes to negative, if I recall correctly. They might be diodes. blue diode in the alley by the light switch. Who watches over you? Okay, so we're looking up SMD capacitor. Marking. Birdhouse in your soul, not to find a point of it. Say I'm the only being your buddy. Make a little birdhouse in your soul. While you're at it, keep the nightlight on inside the birdhouse in your soul. I used to have all those albums memorized. Let's see. Not to find a point of it. Say I'm the only being your buddy. So this is minus, so we do like this, and that little parenthesis dictates where your minus is, and then just in case you have like a brain tumor, they put a plus on it as well. And so somewhere this thing is connecting, and it ain't there. Huh. We could ohm that out in order to figure out where it's going, but it might be going here. Oh my God, my dog is like howling at the front door. We've got another one of these things. I'm going to mark this down as a can, even though this one does look like it's actually configured like a transistor, because it does have the 22 ohm there, and it's got the 10K here going to this pin, and then this one is pulling in a direction. You see how I'm going very quickly. We're marking down everything we possibly can. We don't need to do circuit analysis at this juncture. Marking down what the values are might be helpful. I'm not doing that right now, though. I'm just getting my design down. I wish I could right-click to erase like I can with paint. But this isn't paint, it's GIMP. It sucks. Right, there's some tantalum caps with a mark on the positive side. Yeah, those old tantalums. Tantalums are good at exploding. -0 and +0 volts. No. No, there's not. Unless you specifically say there is some kind of a difference, it should be assumed, because using positive and negative notation with your absolute middle voltage in a system with positives and negatives is irresponsible. And so the question is wrong. That's like those math things where it's down to a specific operation within PEMDAS or whatever you do with the parenthesis manipulation. The question is asked wrong. It's not that one or the other is necessarily correct. It's that the user is not being given the right information in order to make a determination of what specific operation is to be done first. So it's down to the asker of the question getting it wrong. And so there's two answers. See those pop up on like Reddit and TikTok and stuff like that a lot. Twitter is actually a better place for something like that. But you find those quite a bit where PEMDAS is completely ignored, or the execution of PEMDAS is down to like the MD, which is multiplication division. Those can be swapped. And so if your answer is different when you swap those, same with addition and subtraction. Those can be swapped. If you're doing them in the wrong order, well, there is no wrong order. It's only that you do the parentheses first, the multiplication or division second, the addition and subtraction third, etc. So those tricksy little problems they're just phrased wrong. Math, electronics, schematics, it's all communication. And you want to be as clear as possible, which is why I'm using the pencil tool so that all of my lines are as wavy as possible and impossible to interpret. Parenthesis, flat. Oh my God, that was the worst one I've ever drawn. Yoink, 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 over to yoink. It's right on its seam too, so it's a little confusing. Paint Shop Pro. I might have tried that before. Not really sure. Before Adobe bought them out. 2002. It loads fast and has a cloning tool. This is a cloning tool. I think. There's a rubber stamp over here somewhere. You mean like an actual cloning tool? I have these separatists that I got to deal with. Yoink. See what I mean by this not needing to really line up? because all we're doing is interpreting around it what should be there. And then when I redraw this, possibly in MS Paint, oh, this one's tough. Is that just going above, or does it go over? Let's find this on the physical board. Where are we? We're on one of the other censored chips, I believe. Or is this the, yeah, we're up in the oscillator area. I remember Corel. Coral. I don't know how to say things, right? We are here. This is our LM3046. This was one of the censored components, I believe. Or no, this was one. No, 074C. The LM3046 is a 5-transistor matched pair, I think. And then here we have, this is the one that I'm looking at right now on the drawing. And it's a little blurry what was going on up here. And we can see much more clearly with this view that the transistor is not connected to anything there. So let's look up this so we have a symbol for it. What is that? Is it a 1.7? I can't see that well. 1410 5 BC. 1410 5 BC from On Semiconductor. Intelligent power and sound. I don't think that's right. Did I get it totally wrong? Hold on. 14105. That's a V. That's a straight line. 1410. Is that a 5 or is it something else? I don't think it is. Or I think it is rather. 1410. It could be a 6. 14105 BC. 105 BC. Put datasheet on it. It's like I searched that before. Panel feed through terminal block. No. Tycho electrics no. 900Q 5DS. What? Interference suppression film capacitors. No. 14105 on semi datasheet. I don't think it's a PMIC. It's definitely not a PMIC. That is not our chip. That's an LED driver. Really? All About Circuits is a human check now? 145090. That's not even close. I think we looked this up before, and I'm forgetting what we did. PRFH13? Or is that just going to be tracking stuff? That looks like a BG. 14105. It could be a 6. I'm pretty sure it's a 5 because I see kind of a break in there, and that looks a little flat to me. Let's try 14106. MC141 hex Schmid trigger. We are hex triggering 14106 BG. Mark that down. 14106. And we've got a box. What does a hex Schmid trigger do? It barks, apparently, according to my audio. Well, it just barked at something. I don't know. I hear, whoa! Schmidt trigger. So Schmidt trigger is like fuzzy logic. It'll latch and then it'll unlatch and it'll give you a little bit of wiggle room in your signals so that you don't bang back and forth on something if it's close. So there would be a trigger level where it goes high and then a trigger level where it goes low. And so it gives you a nice fuzzy whatever going in the middle there, right? It's just so you don't what do you call it? chatter. It's an anti-chatter measure. Yeah, they're good for debouncing and stuff like that. So we have power in and we have ground. We have a whole pin out here. Pin 14 and pin 7, okay. So pin 14 and pin 7, VCC, VDD, and then what between pins 1 and 2? That's going to be tough to draw. Thanks to the wonders of digital manipulation. That's what the hell? Fine, I'll draw it individually then. This is gonna suck. Pins, what is it? 7 and 14? Pin 7 is SS. Okay, 7 is, this one is ground. Oh, select none. This is gonna be horrible. This one is power. And then pin 13 and 12. Yeah. That. Okay. There's going to be a lot of these. The fun thing is, as I said, schematics are communication tools, and we are very pixelated in this communication system. So I need to make sure that the silhouette of everything I'm drawing is very identifiable. Otherwise, future me is going to look at this and get very mad at myself. It's hard to see right now. This will be easier to see later, and I'll put it on a white background when we do the final analysis of what's going on. And then this is going to take me a little while to manipulate into a usable schematic. It's going to take me a couple tries. I'm going to put circuit structures together, figure out what's where and what's what. This is going to take a little bit of scheming and looking stuff up on the internet and stuff like that in order to get structures that look like things that I would design together. But that's all it is. It's just grunt work. We're just doing the work of figuring out what this thing is, what this doohickey does. There's been a lot of discourse about the various fallouts, and I was reminded about how much I love the quote from Harold, which is the not quite ghoul, is more of a what was that called? FEV mutant. But he said about the water chip is that, well, technically it's a thingy, which is one of my favorite quotes. I mean, he's talking about how it's a MacGuffin, but at the same time, I love that quote. Plot-wise, it's a MacGuffin. Whatever we can see. If we can't see it, we don't worry about it too much, because we have a whole nother layer of PCB to observe. And I'm just getting these. I believe that's going to connect there. That kind of seems what it's going to do, but sometimes those are not correct. It would have been nice if the engineers had done this, but I guess they couldn't be asked. Acid Labs! You've fooled me for the last time. Now I must figure out how you work from your bones. Put a little end on that just to be nice. All right, dot there, come down here, over this way. This one, up and over. And then, what are you? You are, God, there's so many chips here. All right, this one is, I think it's a TL074. Let's take a look. So that was that one. We are now below it. Oh, this is the LM3046M. Theoretically, it's the LM3046M. So let's mark that down. Or no, wait, this one is. You can even read it from here. So I'm going to box this one. Three. Oh, it's terrible. I need to get closer to write this properly. 3046 M. Where can I put that? Because that's going to get in the way. Yeah, whatever. Just immediately draw over it. The box there. This is very scatterbrained. It is very good work that we're doing, though. We're getting a lot done in terms of being able to troubleshoot this and figure out what went wrong. Why is this specific part that I just outlined heating up? Why is it getting hot? It should not be doing that. The more I can parse this out, the more I can get the different symbols to not overlap, the more I can identify structures of functionality, and the more information I can glean from it, and the more voltages I can calculate. That will help me probe this thing and figure out what the heck happened. Who killed it and why? Was it Dave? Dun dun dun. This one there, that's a big guy. Let's just do this one justice. Big guy there, big hoop there. Square, this thing going in there. Coming out here, going up to there. Circle. Circles and squares. The reason I'm marking this down 1 for 1 is because I am then going to take the bottom layer and mark that out 1 for 1. And that'll give us a better idea of exactly what's connected. And then we can view this all at once, and it'll be this really shitty drawing, but it'll be able to tell us what the heck is going on. Hopefully at a glance, but you never know. And there could be a trace that runs the entire underside of this component right here. Now, we were trying to find out what this thing does. What is this chip here? Where are we located? We are right there. So I'm going to go here. Nope, I'm going to go here. And so we are located right, I mean, it's this one. So this is a TL074. 074. And the TL074, we'll look up a data sheet just to be nice. TL074. We may still have an unknown chip on this thing, too. Data chart. Show me the data sheet. Low noise FET input operational amplifiers. High slew rate. This is the same data sheet, actually. There's just more symbols on it. Oh well. TL074X, DNS, NS, PWJ, DYY, and W. Okay. Pin 1, out, minus plus. VCC is at 4 and 11. So 4 and 11. Pin 1, this is a slash right here, a 45-degree angle, which means pin 1 is right here, which makes sense because it's a capacitor right here. So it's likely, well, there's one on both sides of the chip. That's a little odd. Let me double check my logic on that. Every time I think I've got a detail straight in my head, it's backwards. So I'm thinking pin 1 is on the slash, but let's just check. It might be on the opposite side. Pin out, IC angle. I need a picture, nice pretty picture. My computer just sped up for some reason. Or I could do IC pin 1 markings. Somebody's using like a drill outside. Okay, so the slash is on the opposite side. Oh yeah, there's some high frequency drill outside. That was really weird. Notch, indented dot, printed dot, notch. I'm looking for the ones with the angle on it. Okay, angle, and then pin 1 is on the angle. Okay, so pin 1 touches the angle, which means that pin 1 is here. Pin 1 in this chip, where'd it go? Where'd it go? Where'd it go? So pin 1 is out 1. 1, 2, 3, 4. This one would be plus. and then this one's V minus. Then, I guess since it's just, wait, pin 1 down there, yeah, VCC plus, it's 180 degrees from where it is right now on this. I guess I could have cut paste the whole symbol in there. That would have been kind of neat. I could have just cut pasted like 10,000 symbols on this thing, and it would have looked like a professional schematic. Well, whatever, who cares? Okay, so pin, that's out. So this goes to here, and we do doot, doot, doot. That was a little bit big. That one goes around like that. This one goes here, and then this one is plus. As long as one of them is marked. And then on the opposite end, the output is the same direction. This one is plus. Here they go out like this. Doot, doot, doot. And that one wraps over like that. These are op amps. So this one is plus here. And then this one out like that. Triangle. Around like that. This one like that. Plus. Nothing special. Just a simple op amp circuit. Drawn expertly by somebody who is very familiar with straight lines. Everything is totally wobbly and it looks like crap, but we'll draw it neatly when we redraw it in MS Paint. Father, why don't you use XYZ? Because MS Paint. It's fun. It's fun to make really janky drawings. Come on. Little. Draw something sloppy. Do wrong by a project. And that. Okay. That's our TL074. I don't know what we draw for this one. So this one's kind of tough, and I don't even know if we have exactly the right part, because this was one of the unidentified ones. So we're going to look up this symbol, this chip, and I'm going to draw it in as it is. So it's an LM3046. Is it LM? Yeah, LM3046. LM3046. What is in you, chip? What you do? Data chart. Force AI to get out their pencils. Well, you need very specific AI in order to ask it just the right question. And I don't know if that would be able to do that. There probably exists somewhere some type of AI that would be able to do that, but I don't know what it would be. And I wouldn't trust it to do anything because AI routinely lies. You know, the language model is designed to speak to you clearly. That's all it's supposed to do. So when you get a language model and you start making it do stuff other than speaking to you clearly, there's you should not trust the information as well, even though it speaks very clearly. And oftentimes it will draw from things that are correct, but it will also draw from things that are incredibly wrong. People have tried to make AI do a circuit, just a picture of a circuit, and it gets it completely wrong. Now, AI in electronics has existed for a long time, longer than these language models have. They've been trying to make the language model do like circuit design. No, man, we have trace layout design from AI dating all the way back to the like 90s. This has been a known thing for a long time, and have been working with it. So AI pens with CYMK ink mixing depending on what you're writing. What? Copper. I don't know what the words are that are coming out of your mouth sometimes. Where do you get this from? LM3045, 6, and 86. So this would be the outline of the transistors that are in that package. And these are ultra duper, super duper matched. 5 general purpose silicon NPN transistors on a common monolithic substrate. 2 of the transistors are internally connected to form a differently connected pair. The transistors are well suited for a wide variety of applications in low power systems, DC through very high frequency range. They may be used as discrete transistors, blah, 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 blah. I believe they're super matched. 2 matched pairs. Oh. So I need to write this into this symbol here. Complicated. So pin 1 is what happened? That was a Dat Deets resub. Try 6. What? With a Prime for 66 months. We don't need no water. Let the subscriber burn. And a lot of blood. I actually met the keyboardist of whatever happened to Bloodhound Gang after their little fame, their foray with being a famous band. Worked on that giant globe. Okay, so pin 1 is down here, and that leads to, oh god, the structure. What is this? So this is going into a base like that, and then 1, 2, 3. That's 1 pin for the 2 outputs. That. This is going to be difficult to see when I'm done drawing it. That. And then these go like this. What the hell did I draw right there? Oh, I see. Like that. Holy crap. Then this one is another transistor with this up here. So that comes down here, goes like this, that. And then I've got the arrow here. Arrowed. Goes here, comes up to here. And then we've got another transistor here. And then 2 pins down, we have another transistor. And it doesn't have a unified power input because it's just a bunch of dumb transistors. That's going to look terrible when I come back through. We'll be more neat and fiddly with it when the time comes. Right now, we just do whatever it takes. Okay, what's next? We keep going with this. We keep doing the traces here. I gotta look at this through the microscope because this is still a little bit blurry. Luckily, we have it nice and up close. It's a good thing these aren't the only photos that I have of the thing. All this flux from when we soldered this thing in. Narsty! Father, why don't you like flux? No. Okay, so all you can see is this one. I'm gonna clean this off. I'm gonna clean it off with stuff. Get a Q-tip and some goof off. And just get that flux out of there. Forbidden candy coating. It tastes like caramel. Caramel. More like enamel. Whoa, we've been sitting down for a little while. You guys have been sitting this whole time. Stand up. Hello? This isn't dry? Oh, there it goes. You don't want to let this stuff linger. You have to? Do you have to let it linger? Because it's bad for plastic. But there's not a hell of a lot of plastic on this board. A lot of dust, not a lot of plastic. And the cotton ones leave stuff behind, but at least they're slightly renewable. I actually do have an ultrasonic bath now, so technically, if I really wanted to, I could throw this thing in an ultrasonic bath and really clean it off. But it's not really necessary. Not strictly necessary. All right, you can see the traces way better now. Yeah, delicious earwax. Okay, so we know that this is connected. Yep. Box there. And you can do this to just about any circuit. It's not against the law. You can just take the ducks from the park. They're free. I have 27 ducks at home. The box question mark symbol is our own special symbol here for the unknown. I had my nephew make that joke to me, that meme joke, and I'm like, you don't know who that is. You really shouldn't. You're way too young. Well, politics is like your pecker. You really don't want to show it to people all the time. Especially not kids. That's not really that political. It's just, you know, a complete conspiracy nut, but whatever. Ducks are able to freely leave if they want to. They know the safety dance. The safety dance? Oh, you can dance if you want to. You can leave your ducks behind. Because you shouldn't be making friends with ducks. They're animals. It does not seem like it's that safe of a dance, to be honest. We don't know what's going on under the chip, too. We're going to have to take a close look at that and see if we can make any assumptions. I probably should have taken a quick little screenshot when we were actually under the chip. We have a view of under the chip, but this is going to take like a couple nights of me going through this and like redoing it in order to get it right. I've spent many hours on schematics like this trying to get them to look right. Push comes to shove, hopefully this one is easy and it'll all come to fruition very quickly. Because we are dealing with something that is built up of a bunch of different known audio components. I believe that that filter is a diode filter. So we do need to go back through and make all the symbols into diodes. But the diode filter that we've worked with, I mean, they're structured all just about the same. It's just a matter of tuning the individual ins and outs in order to get the voltage levels that you want to deal with at any particular point in time. So that's going to be the variance on some of these components. What is this symbol? This might be a voltage regulator. Although we're not dealing with lower voltages on this, so maybe it's not. We can look this up, though. This type of SOT 223-5 package. It's a little bit more complicated of a package name. The reasoning behind it is that it has 5 pins, and it is an SOT 23 size. SOT 23 are those transistors that I was talking about before. They're the 3-lead boxes. It might not be an SOT 23-5. That's the closest approximation to that pinout. The specific sizes probably put it into a different package type, but if we know something close enough, we can also see the numbers that are printed on the outside of that chip. And so we might be able to figure out what this thing is doing. Typically this package here, this thing, is like voltage regulators and stuff like that. That's what you'll see much of the time with those, although there is a very large variety of devices that come out of that package. You guys make the sex jokes on your own. I'm just going to keep talking. So many little boxes and stuff. And when you look at a schematic, you can think about it in these terms. I mean, the caps and the resistors and stuff like that, they all just boil down to a symbol, a hieroglyphic symbol that's going to tell you where the copper is. That's all it is. So our manipulation of this is very much what goes on in the head of an EE when they look at a schematic. Those that are tasked with actually building circuit boards out of this stuff go through this process all the time. Sometimes, yeah, you can have single op amps in that package as well, but we are somewhere around the voltage manipulation. I would think that this would be where you'd put your input voltage manipulation right by one of your big headers. We don't know, though. What just happened? Oh, I cut. Control Z. Control Z again. I hit Control X and it deleted everything. Boy, that would be a funny joke. File, save as. Save as. Let's put that in. Oh, GNU program. It doesn't know where my Windows shares are. So we'll just put it on the desktop for now. Desktop. I'll just call this M303 Schem Trace. Is the safety dance not OSHA approved? This is a scandal. That goes to a box. Goes out here. Out there. This is going to be a hideous looking schematic when I'm done. Absolutely filthy. But it should be serviceable to translate into an actual working schematic. Probably could have plugged in the pen tablet to do this. Might have made it a little easier. Chad bought me a tablet. It's a pretty cheap one, but it works like a tablet. Fairly useful as one, and I haven't had a chance to really use it for anything. I plugged it in once, and then forever I have that little pen symbol at the bottom of the screen. But it didn't seem like it was as functional as I think I could have had it. Like, if it was one of the ones with the screen, it might have been a little better. The whole point of it was so that I could draw by hand onto something like GIMP and be able to like draw this stuff a lot faster. But I've learned the mouse so well that I don't really know that that's necessary. Ugh, so well, and then I draw the most hideous capacitor known to man. Something's going on over there. Well, it's not jumping to another layer, so... And that one is going down to there. Up to there. I think that is a voltage hookup, so we will put this like this, I guess. It's terrible looking, but I think this is the power input over here anyway. Put a dot on there just so I know. And then this goes to here. There. 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 Whew. We are getting there. Would it kill them just to like have this make sense? Would it kill you guys to just flip these 90 degrees, or is that just completely out of the cards here? I have a feeling this connects like this. I'm gonna go like this. Up to here. Or I'm gonna have to draw another one of those big weird symbol-y guys. That one goes somewhere. And then we've got big boy here. With a big plus sign. Ugh. Yeah, this is a whole device that we are reverse engineering here. So this is a lot to go through. The I/O is going to be particularly vexing because I have to figure out what the pinouts for all of these things are and how they connect to the next layer of board. Now these are all power, so those will be significantly easier. That one. Draw a billion little things here. Pins, 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 pins. I don't need the whole connector. We're not using the whole connector. But I guess just to be a completionist on this thing. What is an infrared pick going to do for me? A thermal image of the board? We have everything we need right here. I cannot see underneath this stuff, even with thermals. An X-ray would be probably what you're looking for. No, you can't really see through these symbols unless you're X-raying. Thermal is not going to see through that kind of stuff. I have taken X-rays of boards before, and it's really, really cool because you can see through everything. And you can see all of the bonding wires that go to the silicon chips. As well as inside of the package of the IC, you can see the substrate, or the metal that is epoxied in that makes up the pins. I'm trying to go slow on this so it's not a totally wobbly line. Careful now. God, I got to do 2 more of these things. Ugh. Gross. There's so many pins. The thermal vision is not as amazing as everybody would make it out to be, but I really do wish that thermal and night vision was done properly in games where they're not trying to be a mil sim. So Fallout, of course, particularly comes to mind. There are things that you can see in night vision and in thermal vision that I think thermal vision is just a mod that they put in, but like it doesn't quite work. And they get around it by calling it a Chinese prototype. So if it sucks at what it does, you're like, oh, well, it's a prototype. But the night vision is particularly annoying in Fallout because really all it does is make everything bright with a green overlay. And I know they were doing this 10 years ago, but like night vision looks totally different from what they did. And it's something that they can completely do within their lighting engine. It almost seems like what they've done is a placeholder for later getting night vision correct, and then they just never went back over it and fixed it, because everything should be a hell of a lot more contrast and a lot darker because of the way night vision manipulates photons. And it's annoying too. You know, it would be nice to have actually functional, but you know, whatever. Maybe it gives you too much of an advantage. Bring GG! Man, why couldn't GNU Image Manipulator Program have come up with a better name? 13 months. Yeah, thank you for the 13 months. You got a 1-month-old. Yeah, honestly, like I'm sitting here. Some people watch me at work because it looks like I'm doing electronics work. Jokes on them. But they watch me during work, and it's like I'm sitting here yelling about my GIMP and how I can't get it to do what I want it to do. It's not what you think, boss. Yeah, a lot of milsim games. That's because night vision used to be in the realm of like really, like it still is. An image intensifier tube is still $2,000 with an unknown amount of life on it if you're getting as cheap as possible. Because it's like, I mean, it's like an otherworldly kind of technology, right? And it's all ITAR restricted and stuff, even though we left a bunch of that shit in the desert. But the way, I mean, you can spend about 10 minutes on YouTube and figure out exactly what it should look like. About 10 minutes on YouTube is all it's really going to take. And you'll be able to see exactly how it handles light and what infrared light does with it. Like, infrared is insane with night vision image intensifier tubes. And, you know, they all get it wrong, and they're all just like, ah, this is fine. But it's I don't know. It'd be kind of fun if a game that's not exactly a milsim did do justice to night vision, because you can do a lot of really cool things, especially in the horror genre, with other types of vision that have shortcomings and advantages. So it'd be kind of cool to see that, you know, taken upon as a mechanic. Oh, did Veritasium do a night vision video? I'll have to watch that and see what he said. I've always had an interest in this stuff since doing the research stuff in the early 2000s. A lot of these like tactical bros now are in, for some reason, I guess they all went out and got jobs, and now they can all afford like night vision stuff, so they're all running around in the dark in all their milsurp gear, actually new military expensive gear. You know, like, people like to put on a fancy dress and go to the ball. In the same way, these people are putting thousands of dollars of stuff on them in order to show off to their friends and run around in the mud in the dark. I guess they're getting exercise, so that's all good. That's all well and good, but I have had a passing interest in this stuff, and I've had like image intensifier tubes from old research equipment and stuff for quite a while now. So it's all just starting to get, not just, it's been getting super popular over the past, you know, umpteen years, because all that stuff is now available. Those Gen 3 night visions are now completely available to these guys. But it's just interesting to see because there's so much expensive stuff out there. What is that? What is that? That looks weird. It's a 1K and it's on these guys. Yeah, there we are. There is... What was I looking at again? Wait a minute. Oh, the other side of the 1K. We could check what it is with the camera, but is it just like a solder drip? What is that? Yeah, it's just a drip of solder. It just popped right off. Weird. Answer the question: how does night vision goggles? How do they have no latency? Oh yeah, because it's a diagonal layered sheet of an incredibly, like if it's a phosphor covered high voltage plate, and when a photon wibbles around and hits it, multiple photons are released and they hit the next plate and then they hit the next plate, the next one, the next one. I want to hear what Veritasium has to say, because I think he might go into the technology in a better display. He might have a better way of explaining it. Night photography, yeah, if you look up at the stars in night vision, it looks amazing. But yeah, they have no latency because they are more or less a physical system running at the speed of light. Russian surplus for the early stuff, yeah. And the problem is Gen 1 and 2 are not that useful. Gen 1 and 2 are very difficult to work with because, I mean, they're fine. You can see plenty of different, you know, cool stuff with it. But if you accidentally look at something bright, especially the sun, you can destroy the night vision goggles. It'll put a spot in the night vision goggles temporarily if you look at something too bright. Gen 3 is able to moderate that and keep it from breaking the device. So it's a much more versatile technology. Beyond that, I don't know anything about the later generations. So I know there is a technology where you have a CCD sensor that is super duper sensitive. And so when you look through it at night, it looks like daytime, only there's slightly different like handling of color and stuff. It looks pretty much like daytime, and yet there's no light at all. You can see color in the dark, which is crazy. But I think the units are still very big. How would you recommend going about reverse engineering a PCB board for the first time? You're going to need a multimeter, first of all, to answer your questions of what is connected where. There's a certain amount of knowledge of how traces are routed and stuff. Find an easy one to reverse engineer. If you are stuck and you absolutely have to reverse engineer a board that's extremely complicated, take pictures. You may have to look at, like what I'm doing right now, basically, is layering the top and the bottom of the circuit board and then drawing what all the components are and going back through and rearranging that drawing again and again. What you're going to be doing is if you're trying to figure out exactly how a circuit is working, how it's doing what it needs to do, you need to have, well, you should have a little bit of experience with circuits. If you don't, you're going to be Googling a lot of stuff. There are fixed forms for how engineers write down circuits. If I have an amplifier, like an op-amp amplifier, there are certain ways that I arrange the components in order to communicate that to other engineers. The whole purpose of the schematic is to communicate what the design is. Now, I've seen people make designs where they literally just are programming what's connected to where, and it's just a big mess. That's all well and good, but in the end, you're really trying to communicate with other engineers. So, I mean, while all bets are off and nobody has to do anything, there are no laws about it. Obama isn't going to kick down your door and arrest you for drawing your schematic wrong, although some people are convinced he will. You should follow a fixed sort of way of displaying things that is common to engineers. This is why reverse engineering is the realm of the galaxy-brained electrical engineer. You don't need to stick to one standard, but you should find a standard that you like to stick to. And nobody is necessarily held to that standard. It's yeah, a lot of institutional knowledge, and well, not really. A lot of knowledge of just how things go together helps. You can, of course, from a completely amateur standpoint, reverse engineer a circuit. It's going to take a while, and you will learn a lot in the process, but it'll help you in a great degree if you get a lot of reference material and look up how other people are putting together stuff. Where does this one go? My picture isn't good enough to see where that one goes. Where do it go? Let's take a look at the actual circuit. And then apart from that, just prove me wrong. Prove me wrong. All the shit that I just talked was completely out of my ass. As somebody who's been reverse engineering things for 10 years previously for Mr. Government Man, you can just prove me wrong and do a great job learning and reverse engineering from nothing. But it's a struggle. One of the most important things to do with the reverse engineering is to take a step away from it and give your brain a break. If you're working on it constantly, one of the big things that I do is between the phases of this, take a break, let your brain break, and come back at it with a fresh perspective. The other thing is to draw your schematic, draw it again, and then draw it again, and then draw it again, and it'll become more organized every time. Well, what I'm going to do here is I'm going to take this bird's nest, and I'm going to redraw it in MS Paint, and then I'll probably draw it again. If I actually had a CAD program, I don't like using the CAD program to put down just the schematics, but if I was doing that, then I could put it all into the schematic program, and then I could kind of figure out how to rearrange it. That's what we used to do, and we had a particular schematic manipulation program that had a lot of logical shortcuts, and so you were able to fly through the design and kind of throw things around. Makes me wonder if you could counter night vision technology in that time by lighting of flares and magnesium. Yes, yeah, that is exactly what you could do. But you can't anymore because they moderate the amount of light going into them. You can no longer damage them with that. If you had even like an entry-level infrared flashlight, you could really mess with people. Thank you for the advice. I have a simple-ish PCB from a power bank. That runs 18650 cells that I want to use to create my own pack. So the important thing for you to do in that case, the integrated circuits that are on the board, the first thing we do as engineers is figure out, first of all, what does this circuit board do? Well, in your case, it's a power bank. Okay, cool. So now I know the class of electronics that I'm looking up, the things that I need to know, and the sort of types of stuff that I need to know. The second thing to do is to look at your integrated circuits and figure out what they are, what they do, and what the dog doing. What is this 14106? And it's going to be part numbers. There's something particular about the way you search part numbers. You know, part number data sheet, part number manufacturer data sheet. Get rid of some of the part numbers so that you don't have all the specific chip information and packaging information on that part number. After you figure out what the chips are, that'll give you a better idea of what all the circuit elements are that are helping that chip out. Engineers are not incredibly creative. I'll just say that right now. Engineers are not incredibly creative. What you'll find in a lot of data sheets is, well, not these are generic parts, but in something like, my dog's barking. In something like, you know, a more complicated ASIC, an application-specific integrated circuit, something like the dual operation transconductance amplifier will not necessarily have a common circuit, but in the more specialized electronics, what they will do is they will have an application circuit in the data sheet. And so you'll see that application circuit structure in the components, and you rearrange them so that they look kind of like this. So this is not necessarily what's going to be on the board for this, because this is more of an amplifier circuit, and amplifier circuits take certain forms. You can Google what they do. But in the case of a power bank, they're going to be using a charger chip, and the chip will have a recommended circuit. Hopefully it's not Chinese. Hopefully you can find an English data sheet for it, because sometimes the Chinese data sheet, sometimes you can find the Chinese data sheets, but you know, it's in Chinese language and you need to translate it over, and some things can get lost in that. We've dealt with that a couple times, but oh yeah, the ones where they have specific like cooling and current requirements, and so they're like, when you lay out the board, just do this, and you're like, wait a minute, I said that's exactly what they did. So you know, not incredibly creative. An engineer sits down at a desk and goes, I need to make a power bank, and they're like, power bank chip, and they get the chip, and the chip says, this is what you should do, and they're like, okay, and they just do that. And that's all there is to it. So you know, you might luck out. You might have almost the entire design of the power bank minus the locations of components and like the special features, like is there an LED? You'll have almost the entire design in the data sheet for the chip. Well, 6 of one, half a dozen the other. Why reinvent the wheel? Yeah, sure, but it is just incredibly uncreative at times. You just buy the ASIC and build the circuit. I mean, there's not much else to it, but it's fun when you figure that out, because you can just, but wait, they just did what was right here? Okay, we've still got a lot of stuff to go through. We still have unknown chips and circuit structures. I just want to make sure to dot my T's and cross my I's. Oh, it's so funny because he mixed them up. Now, we were looking in an area that I had to kind of look at the circuit for, but right now, I just want to fill in a lot of these circuit structures so that I can figure out what's doing what. There's a lot to this thing when you really get down to the brass tacks, huh? TACKS, the tacks that hold together your furniture. They're made out of brass. Do not know what all is going on here. Some kind of amplification. Over here, I'll just fill in all this stuff. And that'll give me more of an idea of all of the individual stuff that's hooked up. This is doing something weird. I think, and this is just going to be an assumption here, this is doing that. Why would it do that, though? Is there another thing blocking it? No. Why would you have it do that? That doesn't make much sense. All right, I'll just draw it up to the thing and we'll figure that out later. There's a lot of connections in this area. A lot of density. Yeah, I hope that helps you. Time will tell. Up to here. We don't know this chip. We'll see if we can look it up, if we can see part numbers on it. But part of the reason why we're doing this is because alphalabs.de decided, is it Alpha Lab? Am I getting that right? Wait. Acid Labs censored their part numbers. They tried to keep the information from us. They scratched off some ICs. And so Dave plugged in his module wrong, which is a very easy thing to do given the design of the headers of this thing. And they tried to keep these parts secret from us. In order to find out what Dave blowed up, I need to reverse engineer the circuit to figure out how it functions. It'll give me a little bit of insight into how it blowed up. This is looking like the oscillator portion of this synthesizer. See, the 303 has a D to A, a digital to analog converter in it. And it digitally creates the sounds. The 303 is actually a digital piece of equipment. It's not creating the wibbling waves all on its own. That might go to here, it might go to there. We might have to ohm it out. See, with this, what we're not doing today is ohming it out. Ohming it out is when you sit down with a multimeter and you put it on the ohms setting, and you figure out what the layout is by figuring out how much electricity your multimeter can measure across the various points of contact of the circuit. 0 ohms meaning that there's no resistance between the two. That is an extremely useful way of going through things. It'll give you a lot of great information. Don't use the beeper. Don't use the beeper. Be a friend and don't use the beeper, because the beeper doesn't give you all the information. If you have like a 10K ohm between two pins, well, maybe you've tested it here and here, and now you've found out, you've verified even more of your circuit, right? You're not getting all the information that you could possibly get. Ohming is an extremely useful thing in reverse engineering. It is how we will determine some of the harder to see things on this board. How do you trace multi-layer PCBs? Well, you've got multiple layers of image. I could just do this, and then I could go do like a nice dark blue, and then I can view the side of the board, and I can go from here to here, right? And now I know that we're connected over there. I haven't traced out the rest of this area, but yeah, that's just how you do it. You're just working multiple layers. This is going to be an extremely sloppy, I mean, look at this. It looks like I scratched this on a hospital wall, but this will give us a lot of really good information about what's going on with the circuit, and we'll be able to sort of suss out what the circuit structure should look like after the fact. But I need to do it completely first, so it's going to take a minute. But yeah, this is the cool technique of tracing out circuits. Where does that one go? That's one for the multimeter, because it might go to here. That goes to ground. I'm going to mark that as such. It looks like that capacitor might go up and over, but we'll have to figure that out at a later date. Oh man, we've been flying around so much that I haven't been able to get to a lot of this stuff. There's a lot still here to do. And when you get to like 4 or 6 layer PCBs, you don't do it this way. This is a way that is strictly for 2-layer PCBs. When you get above that in layers, things start to get very complicated because you don't know what's going on in those sort of interstitial traces. Now you can surmise a lot of what's going on. You can ohm it out a lot of the time. Those internal layers don't have any components on it, and you'll see things like blind vias. Like, see this right here? This would typically be an indicator that this is a 4-layer PCB. Like if you had a ground plane above this thing that was avoiding that pin, you would know that, oh, that's routing to an internal trace. And then you could ohm it out with your multimeter in order to figure out what's going where. But it gets very difficult to do. It's quite a lot of hassle to go through. That's just not worth it. Could be a couple mistakes here. In which case you can, ohming it out is of course your best friend, because all these things won't lie to you in the realm of electricity. What the heck is going on with this stuff? See, this is just an exercise in drawing things really crappily. And then we'll go over it again later and figure out what the heck's going on. Could that be 2 transconductors amplifiers? I don't think so. I'm just going to draw a box around these. We'll figure out what they are later. They could be dual Zeners. They could be, what are they? Those Schmitt trigger current limiters. We've seen those used in mutables instruments where you have a Schmitt, is it Schmitt? No, not Schmitt trigger, a Schottky diode barrier. You have 2 Schottky diodes. One goes to your max and one goes to your min voltage. And when you get outside of the voltage, it'll bleed off all the excess current into the positive or negative limit. So you can keep from blowing up stuff. Like microcontrollers, they'll have those internally to limit, to make sure that you don't blow up your circuit if you run 5 volts into your 3-volt input. One of these, one of these, one of these. It just goes on and on, huh? If that was a puppy coming downstairs, I really want to put my camera over there. You guys could have a sleeping pooch while I work. This is looking kind of familiar. Pins. What is it? 1, 2, 3, 4, 5, 6, 7. What? Is that 7? 1, 2, 3, 4, 6. Yeah. Pin 8 and pin 11? Not quite. Pin 8 and pin 11. I mean, this looks like it's a power pin. That one goes there. This looks like something that I've made before. Yeah, it's looking awfully familiar. When the schematic begins to get rearranged, I think this will become a little bit more evident in what it is. So we have until then to figure it out. I've never officially used an X-ray to do multi-layer PCBs. I figured that would be pretty fascinating. Not all of us are applied science. We don't all have just like an X-ray kicking about. But it would be kind of cool to get like an X-ray picture of something like this and use that to figure out what's going on. Where do you connect? You ain't connecting there. Yeah, my theory is it's this via. And if we look on the other side of it, maybe we can figure that out. This one. Which one are we on? We're on the top one. No, it doesn't connect up there. Wait, which one are we on? Yeah, the 4072 is right there. That one goes down that way. But then we don't see any evidence of a trace under this cap. And I could pull the cap, but I don't want to do that much manipulation on this thing. Sorry, I'm hiccuping. I had half of a Wawa shorty for lunch. I always pull the old X-ray machine out to do this kind of stuff. Yeah, I mean, don't we all? Don't we all? That's how I make sure that my shoes fit correctly. See, these all seem to be dumping to ground just like right next to it. And then the one that doesn't have a dump to ground is this top one. It has a different circuit, well, slightly different circuit structure. But that one is definitely there. This one is there. That just looks like the right thing. Because even though it's off by a little bit, it's over to the right just a tiny bit. Oh, did I mark that badly? No. Yeah, it's just right there. This one too I need to mark as ground. So is this one. And then so is this. Oh, that was the worst ground marking I've ever seen. I just had the Russian ninja theme pop into my head. That, and then, you know, whatever this one is goes to ground. This one to ground. We haven't really traced anything in this area yet, so I don't know what's on the top layer. Oh yeah, I got right in my own way, of course. We'll come back to that. Yeah, so a lot of the time with the 4-layer PCB, I forgot to mention, is that the internal layers are such a pain in the ass to deal with that they only route power and ground on those internal layers. You're lucky if they do that. Sometimes you get lucky. What goes over here? I love those memes where it's like, what goes on in this area? And it's like the panhandle or like a weird area of Idaho that's like a big, weird outcropping section of the state. Do not know what that V is doing. That's going to be something to ohm out. Maybe it goes to that mid pin. It might go up and over to here. It might go to power. Yeah, that's an ohm. That's something to ohm out. Sometimes on the mega super duper expensive, that's a really expensive thing to do though, is to have every other layer be like a ground layer. But they do that, Doo-doo. They do that, but every via then goes through like 600 layers, and they're very hard to manage. Imagine you have a blind via is even worse. A blind via is when you have a board that's so expensive that they have a via that goes between internal layers. It's ridiculous. We had multi-layer boards with blind vias. Ugh. Not too fun to troubleshoot. Yeah, we had Corellis board scan to it and connect JTAG connections to the chip. Damn, what the hell? That sounds really obnoxious. Yeah, if you're really trying to like bump the price up, or you genuinely have that complicated of a design, oh my god, it gets so annoying dealing with internal layers. Part of my bias against them is the fact that I do a lot of reverse engineering. So they're tough to deal with from a reverse engineering standpoint, most of all. One of the best qualities to have as a reverse engineer is tenacity. I do not want to let the circuit win. I must win. Don't know which one that goes to. This one goes there. Don't know about that one. That's not even connected. Somewhere in here. That's going to be a tough one. That'll be another ohming one, I guess. And by the way, I'm drawing this because I'm always going to have the underlying layers. I'm not going to separate it out from these layers. It's not like a challenge. I can actually look up the underlying layers and then, of course, ohm things out as they become necessary. This is the kind of thing you sit down with a pot of coffee, turn on a playlist, probably Red Letter Media reviews, something you don't have to look at all times, and you just crank away at it until it pops. You just crank that little hoggy until it's done. Welcome to my hog cranking stream. That's what we do on this channel. Imagine putting that in my title. We get a lot of degenerates. Why would you look that up on Twitch? All the way up to there. All right. Okay, I'm back. Let's do a little bit of this. I used to get paid to do this. I used to get paid money to do this. Not anymore. I don't know if this one Duke's right or left. I don't know which way it's going. What does the bottom look like? That one's got something, that one's got something. I'm going to assume that this one goes this way. I probably could have used a larger pencil. It would be more the size of the traces, wouldn't it? That's right, though. This does this. Upside down, plus sign. The point is that I'm going to go back and I'm going to put better schematic symbols on this later. They're going to be more understandable later. And that'll be my first draft of the overall layout. And I could do it in CAD. CAD would keep all of the things connected, and then it would be a matter of manipulating lines that go around. That does make it a lot easier. You kind of untangle your bird's nest and try to get as few things crossing over others as possible. And then you can use that in order to further and further simplify your design. You want to eliminate all of the circuit elements that cross over one another in order to make it more of a clear design. Then you can look up the chips and figure out what the layouts are going to be for that specific chip, especially if it's like an ASIC. You'll look at what the data sheet tells you to do with that ASIC. Or if it's like an op amp, you can look up circuit structures of op amps and see which one matches. AI doing this fast if trained properly. I don't trust AI to even write a sentence for me when it'll like blatantly lie to you. The complexity of this kind of stuff, you know, this is very simple what I'm doing right now. And so an AI could potentially do this very simply. And we were thinking about that 8 years ago. Like we were thinking about, hey, and you could train an AI to do something like this, but it's like some of what's going on here, at least in the later stages, is going to be my interpretation of what's here based on my exposure to many, many different designs in my lifetime. So my own personal exposure to this stuff, I can weed out things that are designed by idiots or things that are designed by people who don't know what a circuit should look like. There's a lot of ways to skin a cat, and the fact that you're pondering skinning a cat is just psycho behavior, and I'm calling the cops. But the thing is, there's a lot of ways to go about the solution in terms of how people generally draw electronics. It's going to differ from author to author. And so in the way that AI kind of does injustice to writing, AI would probably also do injustice to your schematic design. LM317, huh? Let's look up an LM317. Well, if you tell two engineers to solve the same problem, they'll come up with two wildly different solutions. So that's just the law of the land. LM317. Doot. Doot. The problem is, I'm talking while working, so I don't know what the hell I'm saying. 3-terminal positive voltage regulator. Is this a specific LM317? LM317 LM. Adjustable voltage regulator. How are they using this? 240 ohm, R2, 0.1, 0.1. So 0.1 here on a power input. 6120. No device there. Device there, device there. So this would be VREG, and what's my motivation? I can't believe they used the LM317. Pin out, 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 LM317 pin out. Where the hell? Here, nope, that's not it. Well, that's unique. You know, 3-pin voltage regulator. I got like 1 million pins on this thing. So is it LM317? Am I crazy? LM317. SO8. This is a synthesizer module. This is called an M303. It's designed to sound like a 303. The 303 is, of course, the darling of the acid house era of music, where you had all kinds of squibbly bibbly bits in your sound, and that was achieved by this little sequencer with a little filter. This is a module from acidlabs.de, and it's designed to sound like your squibbity wibbly little quibbly thing. And the thing is, like, it doesn't, this module doesn't have the types of electronics that you would typically find in a digital audio processing thing. This has the I think 808 style. I don't know exactly what. That's why we're doing this. Is because we need to figure out what the dog doing. We need to figure out how this thing functions, how it gets its job done. And so the overwhelmingly complicated circuit design kind of got to me, and I decided that I would show off a slightly better way to put together these kinds of things using paint layers in an image manipulation tool. And in your GIMP, what you do is you sound out what the structure of the circuit is with your GIMP. You guys can Google that, and you'll learn a lot. I don't know if this is an LM317 or not. I mean, I guess it is, but VN coming from there with a diode on it. Let's see what the datasheet for this one says. Blah, 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 blah. LM317 datasheet. The data chart. There we go. This one has an SO8. Monolithic integrated circuits, SO8 and TO92 packages. Boy, howdy. Over a load of 1.2 volts to 37 volts. What are you doing out there? I need a voltage regulator that works from, like, I don't know, like a low of 1 volt to 37. Like, whoa, whoa, what, huh? Whoa. 303 is what they use in Sandstorm? No, Sandstorm is actually a preset, if I'm correct. Oh my god, it looks awful. La 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 la. Maybe original? Oh, a Roland JP8080 seems to be the answer. That's getting a little close to the file. Hey, I've seen one of these before. Or at least I just know the Roland memory card slot. They made you use these ancient flat memory cards. It's terrible. Let's get this out of here. I hear vacuum way in the distance. Yeah, so the LM317, let's see what the circuits look like. Let's see if we can find one with the diode on it. I'll bet you we find one with the diode on it. Not quite. Not quite. Application information. This is where reverse engineers live. Yes. Basic adjustable. Voltage regulator. Oh, look at that. 1N4001. Slow turn on regulator. What are you doing over there, 1N4001? Is that you? Is that you right there? Is that you? That's you, isn't it? On the output power. And then we have a transistor nearby. We have the pads for something that resembles a transistor. We have the pads for what might be a transistor, but they decided to get rid of it. Looky-loo. This is what I'm talking about. Look, it's almost laid out in exactly the same way as the schematic symbol. We've got that there. There's actually a resistor above it, which might be this here. That 240 ohm. I don't know where that is. It's like out here. But this is what I'm talking about. We have a physical circuit layout, and then we have the schematic symbol in the application note that is almost identical. There's some elements of it that if you flip it back, turn it, and reverse it, but yeah, that's what I'm talking about. You go into the data sheet, you find the right data sheet, you find the right application note, and there it is, because it's coming directly from that image right there. My butt's asleep. I got a sleep butt. Oh. Yamaha DB8 used a lot of advertising like the Taco Bell bong knives. The one that I love is the 505. One of the sound banks for the 505 is 1, 2, 3. And that is in the intro to Futurama. As soon as I did the what is it? What's his name thing where you point at the screen? I did that meme the first time that I heard the Futurama intro. I was like, wait a minute, I know that one. That's from the 505. It's maybe not specific to the 505, but the Futurama theme is very kind of, it seems like the 505 was very much used in it. 15 volts, they didn't configure it for 15 volts. They just have this circuit represented very closely. Very, very closely. 317L, yeah. Huh. So, I don't know how to do this one. 317L. I believe that this goes down here like that. Although I could be wrong about that. We should probably take a closer look at how this thing is connected. Well, what's our pinout specifically? I'll just mark the pinout next to it and try to remember that I gave this whole explanation for when I rearrange it so that it makes more sense. I don't know if Dave knew that he was dropping his precious synthesizer off in a lion's den, because you're You're in our house now. Can I get like a, I like it when there's a picture. Oh, there's a picture. V in, out, adjust, out, etc. So I'm actually going to core out the inside of this thing. I'm not going to try to mark any of the traces that are under the chip, because that'll be done with the multimeter later. So select none, and then I'm just going to write what the pins are next to the pin. So this is in, this is out, out, adjust. Usually I have more pixels than this. You don't need a lot of pixels though. NC. Sucker NCs. You don't need a ton of pins, or a ton of pixels. Oh, I ain't clicking on no links. I ain't clicking on no links. I'm not in charge of the narrative here. Or wait, did I get the wrong pin 1? No, I got the right pin 1 for once. That's rare. That's rare that I actually got it right. Who knew? Who knew? We've been doing a lot of wacky, zany reverse engineering. I've been working a lot. I've been actually, I've had my head down to do this. I'm going to put a box on this one because it's clearly a transistor that was supposed to go here. But I'll put a question mark, and then that'll look a little bit more like one. Let's clean up some of the boxes over here before I get myself too confused. We've been kind of just going randomly and kind of filling in the blanks for where a lot of these traces are going as I kind of float around this design. There's various things that we need to still do, we still need to connect, and some ohming out that we still need to do in order to make sure that stuff connects properly. Oh, you don't even need to, yeah, pretty much does that for the whole song. For the Blood Rave. You could have just said the Blood Rave song. We used to party hard to that fucking song. People still do. Here's a big resistor. Going to something there. That goes this way. To where I not know do. I will have to own that. This one is some kind of power. Boink. Into our power supply. So yeah, right where the top of the board connects, here's where the power comes in. It looks like something over here. I mean, I guess maybe we're pulling power up and over and then turning it into some other kind of power. Oh, I didn't even finish drawing this thing. Yeah, we've been kind of discombobulated in our tracing of the circuit. But now, you know, as it fills in, I get to go back through and figure out exactly what to do, and where certain things go. And then I've got to look at the front panel too and figure out what the pin headers connect to, because there will be potentiometers and switches and stuff that we need to get into the circuit. And that'll help organize the circuit a little better. That's when you split up the header and you just put a little box, like one single box that gets labeled as like J4 and then pin 15. And so your header is going to be split up all over the place. What you could do in lieu of that, in lieu of doing a split thing like that, is you could have signal flags too. You could do a signal flag and you could call it whatever you want. You could call it Billy. You could just say, hey, this circuit, this trace right here is Billy. And then you would mark Billy as going into the header. There's a lot of different things that you can do to organize schematics, and I hate it when somebody doesn't know all of those different things, because you can create some very nice readable schematics using some very simple techniques that you'll find if you just look at other schematics. Yeah, the thing is, not everybody's going to think the same aesthetics are good, because it really is just, it's just like writing. You think certain writing is certain ways of writing things, you know, Some people like to do a full circle when they dot their I's. Other people have quick notation of things. So, and it varies as much as it does with actual writing. So, it's a neat little thing, schematics are. It's kind of like a second language that people learn in order to communicate electronics to one another. I don't have to speak English for somebody to know what equation I'm talking about. I just have to throw an op amp down. Although I do prefer English, to be honest, because I don't know any other languages. Took a little Latin in college, or in high school. So I definitely don't know that language. Too much mouse clicking. These digital artists, man, they're going through a lot. What up, Riven? Sega Genesis is a sound chip on closely related to a few of the chips in the DX7 synthesizer. I don't know nothing about nothing. I don't know what a DX7 is. Is that like a hot dog? Can I put mustard on it? My entire musical knowledge has been flexed by stream already. We're just learning about how the analog circuits go together in order to make a synthesizer that was fashioned off of what inevitably, what boils down to a sampled other synthesizer. And I don't know what other synthesizer that is. I've saw threads that pointed towards it being an 808. And so I actually have an 808 schematic open on my other computer. The 808 does not do exactly what the 303 does. You know, the 303 samples other stuff. Oh, that's the one that does the dong for Taco Bell. That's kind of funny. So like Acid Labs made this nice acidic 303 modular synthesizer module and attributed its sound to the wrong synth. Dun dun dun. I looked at the 303 synth and it's just got a DAC. It's got a digital to analog converter. It's not creating that sound, it's sampling it. It's sampling it, it's a fake. These are all lies. All the way down, all lies. These are some actual potentiometers on the board. The XD is Yamaha's famous FM synth, frequency modulating synth. Is that what I'm gleaning? I don't know, glemening? It's glemening out. What in the holy hell? Well, this is going to be one of these guys. I'm going to do an arrow, and then I'm going to do this. Since we're doing box resistors, I'm just going to draw a box, and we'll do that. And I don't know where anything else is going. I don't even, this one doesn't even seem to go there. What's going on here? There's a symbol for a potentiometer, which is a variable resistor. And what you have in a variable resistor is some kind of an adjustment that will move that center point. So you'll have conductive material that has a certain amount of resistance, and then you'll have a tap in that conductive material that can be moved back and forth. And what that does, very conveniently, you can make a voltage divider out of it. A voltage divider is when you have two resistors. One is taking your input voltage and bleeding into your output, and the other one's bleeding away from your output to ground. And it can be the other way around too. You can have voltage in, power, ground. You're bleeding it in two directions. So if you have a potentiometer, one of those resistors gets smaller and the other gets larger. And so you'll end up moving towards one end and biasing it in the direction of either positive or negative. So if you need a voltage input from rail to rail, you put a high value, like a 10 kilo ohm potentiometer on it, and then you have a knob that goes from V in to ground. I work at making PCBs, not populated ones, not my area. It was interesting to me to see something besides copper and green. That's strange because I live with my face in populated PCBs. We started the synthesizer project with blank PCBs. It was quite an adventure. Why does that camera look like it turned a little bit? It shouldn't be looking in that direction. Did I bump it or something? I must have bumped it. Really, I don't remember aiming this camera in this direction. It should be all the way over here. Maybe I hit the cable or something. Anyway, the synthesizer that's sitting on the desk there, covered in crap, is, you know, where eventually all these projects are gonna, I don't know, lead to. But I mean, right now it's all populated and built up. We had a couple months where I was building PCBs that were formerly blank, because I think one of the coolest things about modular synthesizers is that you can buy just the PCB and they're like, good luck, asshole, and you don't get any information about it whatsoever. You have to go out and source your own information, and you have to figure out, how's this thing working? How do I test it? How do I put it together? You have to figure all that out on your own. And it's like a hard mode kind of project. This one is the 1410 whatever. And so that's, okay, so that's what that's doing. Oh, and those two are connected. All right, so we got a little bit more information by just looking at a clear picture. It'll be this totally manic stream today that I'm having. And then the ones that are connected are... I missed. What are you doing there? Shouldn't that be above me? The ones that are connected are those two. These two. These two. Is that correct? That's a Schottky going into a Schottky, or sorry, a Schmidt trigger going into a Schmidt trigger. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay. Weird stuff going on this board. How do you know what the IC is? Oops. In some cases, most cases, cases of non-evil manufacturers, there's a number on it. And you Google the number and you look for that number, that part number. It should be unique enough that you can identify it. Sometimes you can't. And there's various techniques that I've actually displayed here in figuring out how to look up the more eclectic and difficult to figure out ICs. However, sometimes the manufacturer tries to keep you from reverse engineering something. This is a completely evil move, and it's universally understood to be a dick move. We had a lot of trouble figuring out what one of these ICs was, and we spent a lot of time reverse engineering the circuit around it. It turns out one of my viewers was familiar with that specific chip, and they knew from some of the support structure. And again, like I say, these engineers are putting together a device that functions in a particular way, and they've chosen their parts based on these parts performing specific functions. So why then would you go in and totally alter what the circuit layout is if they're suggesting a particular circuit layout to run their chip and perform the tasks that you want them to perform? So it stands to reason that if you know the surrounding circuit structure and you're vaguely familiar with functionalities, you can zero in on things like, oh, this has a weird voltage pin, or oh, this has a weird input and output, or oh, there's a coil here, which are atypical things that you would see in circuits. Like, for instance, having a diode on, where are we? Yeah, having a diode here on some kind of a voltage line. Used to work with dealt with a crystal, I used to work dealt with a crystal group called Hong Kong Crystal. Had no marking whatsoever and didn't have a clean room set up either. Take that as you will. We ran into that with crystals again recently, where they're just totally undefined. Like, you can't find any information on them at all. I think the only way is to like get a crystal tester that could just look at oh, that's what happened. So when I stood up out of my desk, I nudged the camera. I got a camera set up on my, just on the stuff over here. My co-host stuff. Yeah, there was no information at all about anything about the crystal whatsoever, and it was very annoying to try to figure out what the hell was going on in the circuit. Okay, we're making progress. 4:37. We'll go a little bit longer. I'm getting my eyes are starting to cross. There's a lot of stuff for us to ohm out. Figures show the most optimal layout for use of the chip unless some guys spent 10 years with the one chip. No. It's like Yeah, I mean, it's not optimal layout, but it's just like what components you use in order to run the thing. And then sometimes in the application note, what they're doing is they're displaying like, yeah, you should have these components, and here are the equations to figure out what the components are. And sometimes you add this, sometimes you don't. So there's going to be a little bit of variance there. But part of what I was showing was also the fact that the base layout of where the components were matched the schematic very, very. If you took that schematic and you flipped it, you would have this. Just about. They kind of moved the diode around a little bit and did some weird stuff in there, but it was so close to the layout of that thing. It's just, you know, everything gets interpreted. You can move components around all over the place in order to accomplish your goals. But, you know, a lot of the application notes people follow exactly to the T. And I guess that's fine. Sometimes you have no choice. But it's just a thing to look at where, like, I can reverse engineer the circuit and its construction because they didn't deviate from that application note very much. And they didn't even try to move their components around to have them laid out in a more compact manner. They just did exactly what that data sheet told them to do, which is fun and it's funny, and you're able to actually get into the mind of the engineers that produce the circuit. There are other elements that you can mess around with, and if you know, like with ASICs, it's extremely rare. You'd have to know like very intimate knowledge in order to deviate away from the application note. You'd have to be very, very familiar with it, or you know, if it's not an ASIC, then maybe it doesn't need to be such a specific design, and you can do other tricks and stuff around it. But yeah, it's kind of interesting to see. Okay, where are we? There's still a lot to do. There's still a lot of like various stuff that needs to be connected, and we still don't know the identity of one of the ICs. I guess the surrounding circuitry is going to lay that out for us. Big box. Which one are you going into? That moves me around. Yeah, it's not moving around the individual elements. Okay. There's so many things you can do with double-sided PCBs and single-sided. Once you start talking about multi-layer, yeah. Putting components on both sides of the board is kind of evil, though. It's really obnoxious. Yeah, things get pretty compact out there. Keep your head on a swivel. We're looking for the big four. There it is. There's our big four. And that little guy right there. And then we've got that. I'm looking at, okay, so that just goes directly. Just like that. Whew, boy, there's going to be a lot of rearranging that's going to be involved in this. It's a lot of components for me to juggle. What you try to do is unwrap this so that you get as few crossing lines as possible. And with a circuit this size, it's going to be a little bit difficult to do. A lot of also what I'd like to go through is what a diode ladder looks like in somebody else's drawing, things like that, like big structures that'll go together in order to make this M303 happen. And that'll help me organize the various things that I have to draw in the schematic to come. Oh wow, there's still a whole area up here that we haven't done. Oh lordy. Down here, one of these, over to here, get a dot. Anybody else missing down here? No, looks like this is where we are. It's a lot. It's a lot. That one we do know the identity of. We can draw that chip in. I think that's the TL074. Well, this is not looking very TL074 if you ask me, but there's that, and we put a dot there. Circle that, bring that down there. Circle that, bring that over. I'm probably going to have to work on this on my own. That way I don't have to talk to you guys. I don't have to teach you shit. I'm under no obligation. Screw you, chat. No, it just means I can work a hell of a lot faster if I'm on my own. Where is that one going? That one seems to go to here. But why would it go straight down if that... Oh, that one definitely goes here. Yep, that's where it goes. So that goes up like this. We're using a box symbol for resistors because otherwise I would have so many just indecipherable squiggly lines. Question mark. Into there. This one goes up to here. And we get a big question mark. There. Up and over. That's how I do circuit design, follow example circuits, although I'm a software guy, not a circuit layout guy. Software is similar too, isn't it? You just look up something that does the similar job that you only have to do minimal amounts of retooling in order to get it to work for the function that you intend, and then make it do the function you intend, and then move on. That's a lot of similar stuff going on in electronics. You know, I need something that does this. Well, here's how you do it. Here's a circuit. And you're like, okay, what's the application note? Oh, I need these on here? Okay, I'll do that. A minimal amount. Yeah, Control C, Control V. This variable equals 1 because I'm not using it. Now AI can do that. I wonder in terms of circuit design, the similarities between CS and circuit design, if you took that kind of an attitude. Man, you'd have like 50 extra components that you don't use anywhere. What's this voltage? It works. There's some weird decisions in the circuit layout here. Nothing too glaring though. Nothing that I'm like mad about. It's just some things are kind of taking unnecessary. I mean, I guess if we saw the underside of the board, some of these would make a little bit more sense. They did a good job on this board layout though. This board layout's everything's nice and spaced out. I've got room to be a slimy little reverse engineer and figure out what everything is doing. They used a nice size of surface mount electronics that typically would be very repairable, but we don't have the information to perform a repair. That's kind of hard to see. Let me redo that. Select none. Oh my God, this is going to be a beast to figure out. Why would you do it this way? Probably because that's cleaner? I don't know. I do see chat moving. I'll read you guys in just a sec. I want to get some done here. Get my layer done. What are you doing? You're going this way. That's also going this way. But then what's that doing? Let's take a look. Where are we at? We're up here. Boop, boop, boop. And that looks like it's separate, but I don't know if it is. Wires going nowhere. That's what this has. I've seen worse. I saw a BMW design that was way worse with wires going nowhere. I think what they did is they took an old design and they just cut paste a new design on top of it and then corrected some of the circuit elements. It was a mad design, especially for Germans. You would expect them to be a little bit more rigid in their design, but it must have been like, you know, 11th hour Oktoberfest or something like that. They all went out to have a bunch of drinks after work. Because apparently it's the most reliable part about the E46 electronic shifter is the shift knob itself. But the design on the PCB is a madhouse. It's like something was going on there. It must have been like Acid Friday or something. Because they went nuts. There's some weird things about, like for instance, if you're going around a circular cutout of the board, one time it goes in an arc, like a nice smooth arc, and another time it uses 45-degree angles to kind of go around the arc. It's like, why? Why does it do it two different ways? Somebody uses them for new product testing. Ah, okay. Breadboards to proto boards. I've never outsourced the board. I have tons of projects that would be fun to try. The thing about like the process these days, and I've gone over this before, and it's something that irks me, but it's totally reasonable, is that $5 100 millimeter by 100 millimeter PCBs have spoiled us all. And it's just so easy to have a PCB produced that the step where you actually use a solder perforated prototyping board is completely obsolete. There's no point in doing it anymore. Why is this one going down here like this? We determined that this one comes down and around. Like, it doesn't seem like that one's going there. That's going to be one to ohm out, because it can't go here unless this one goes here to this one, and then this one goes somewhere else. You can do a lot of stuff under a pin header. There's a lot of weird things you can do under a pin header. That's why I don't like doing things under a pin header. I like to have most of my circuit out in the open. But, you know, not everybody's doing every detail the same. This is going to be an absolute mess. All right, what's this chip? We are over, we're right here. And so you are HEF or CRX. HEF 416, oh, 4016, it's a 4016. So 4016, do I remember what that is? Is it a logic inverter? 4016. I know the number, I know of the number, I don't know it specifically. HEF 4016 data chart. Quad, single pole, single throw, analog switch. Wait a minute. Is this a 4016 as in a switching IC? Yes. I see. So this would be your digital switch. Probably how they're setting something to switch with the control voltage. I'm impatient. That's a good reason to do it too. No time to wait a couple days for a pro board. Dude, it's less than a week. It's insane. If you get it in green, you'll get it very quickly. Yes, I've seen these in designs before. These are just like digitally operated switches. So we have 1, 2, 13, really? Okay, so how's that going to work? Where the hell's pin 1? Oh, no, it's another one of these 45-degree jibber jams. I hate these things, man. So the 45-degree angle chop. Oh, there we go. The chop is on pin 1. Oops. Pin 1 is in the lower left. Pin 1 is in the lower left of this thing. So then it is this pin right here. And so 1Y, 1Z. What does that look like? Pins 1 and 2. So we got a box here. Pins 1 and 2. And 3 is that one? 4 is that one? Okay. So 3 and 4, we've got another box. And then 5. Oh, wait a minute. 1, 2. What the hell? 1, 2, 3, 4. 5 is the trigger for the... Ugh. 5. This one is triggered by pin 13. 1, 2, 3, 4, 5, 6, 7, 8. 16, 15, 14, 13. That don't seem right. $11 and 12 is another one. And 11 and 12 is triggered by 10. Wait, that's not 11 and 12. Hold on a second, I'm dumb. 1, 2, 3, 4, 5, 6, 7. Well, I counted totally wrong. I get in my own head in the middle of counting stuff. It's ridiculous. I just totally lost my train of thought. 1, 2, 3, 4, 5, 6, 7, 14 pins, 13, 12, 11. Let's get rid of these and draw them again. Oops. Let's take a chunk out of everything. Hello? Delete. Oh, I drew them on the wrong layer. Oh, let's select none. Control Z, all this stuff. Okay, so now that I'm on the right layer to draw on. Yeah, sometimes you tank an entire design by doing that. Large servos can be fun. Cramble the circuits into one board, then I could bunch them. Yeah, it's also way more organized to do a PCB than to do the free wiring bird's nest thing, and it's like, it's so easy now. Once you get spooled up with your schematic software and you've got like your 3D parts for everything, it can be just so easy to just spin a board off and poof, get it made, you know? Part of a company, we do controllers and Avada aftermarket replacement units for heaters and thermostats. Oh, weird. Make a lot of stuff. 300 plus a day. That's crazy. That's crazy, yo. Okay, pin 1 right here. Let's just go pin by pin on this thing. Pin 1 and 2 are opposite ends of a switch. Sure, I'm on the right layer. There's a box representing the switch for some reason. A weird symbol to do for a switch. Guess it's easy on me. 1 and 2, this one connects to 13. 14, 13. Okay, that makes a bit more sense. 13 goes like this. There we go. Bob's your uncle. Now, I don't know if there's a lot going on underneath this board. Yeah, I guess there is. There's a lot going on underneath this board, but I don't know where this one's triggered from. Why are you triggered? Where are you triggered from? Huh. That might run under the board to something like that distributes. Maybe all of them are flipped at the same time. It does look like it's doing something, so it probably goes to one of those other vias that are under the board. And again, that's something that the multimeter is going to tell me later. It'll whisper secrets in my ear. And then pins 3 and 4 go to another box. There, and then here, and then they are set off by pin 5. So 1, 2, 3, 4, 5. Pin 6 is the trigger for another one of the switches. Pin 7 is probably some type of power. Let's see. VSS VDD, functional diagram. Yeah, 14 VCC, 7 is ground. So I would assume that this here, that's VCC right there, that trace. Look at that via pulling up VCC, and then there's nothing else going on. Oh, maybe it goes to the transistor then. Yeah, so this one would be power. Well, some kind of VCC, we won't mark that. But then this one goes to ground right there. So this symbol right there, that goes to here, and then I'm going to just draw a little down arrow, points down.jpg. And then I'll come back to this and go, what the hell is I trying to communicate by this cluster of pixels? Oh, we're at that time of the year, huh? The time when it's you just throw your phone out. 8 and 9. Yep, another switch. Okay, but triggered from the other end. So this, like this, 8 and 9. These are cute little ASICs to use. These little switch emulators. Not like that. Don't come after me, Nintendo. That's not what I meant. That's not what I meant. The ones that I have from Maxim actually, they fully disconnect before they connect to the other thing. Hey, what's up, Gonad? How you doing? Why are you awake? Like, I ask myself the same thing. 8 and 9 are triggered by pin 6. 1, 2, 3. Oh, yeah. 8 and 9, pin 6. And then 11 and 12 triggered by 10. So that's here. And here. And then this goes over to there. Okay. Jeez, that was a really clunky symbol to draw. And this would be a 39, what is it? 4016B. 4016. Whew. Today we have almost done this entire circuit. There's still a couple things left to be done. What was that? Hold on, I'm gonna check to see if I got a buddy. No buddies. I heard her barking at the door, so there's a chance that they close the door and then the dog comes down here because she's in trouble. All right, moving along. We're getting progress done here. I don't know if we're going to get to the rearranging part of it today. I don't think we are, but what are you? And why is that off by so much? Did I accidentally, like, move? No, everything else is on. Oh, probably because, yeah, okay, so we got a cap here. Draw a big dot. And then move that over to there into here. What are you? So this could be another voltage regulator. We don't know yet. Let's draw some of this stuff while I'm here. This is one of the more hardcore methods of reverse engineering, and I like it because I don't have to think while I'm doing this. I can just kind of turn the brain off, and we can do whatever, and I can talk about stuff. So, what are you? What are you? What are you doing in my circuit? That's this right here. That's a TLO72. There's a 72 on it, which makes it a TLO72, I think. 072C, yeah. The TLO72. So then we go to the TLO72 datasheet, which is somewhere in this list of chips. It's the early one because we dealt with it first. And here's our TLO72. So pin 1 is there. This one has the slash on it, so that makes this pin 1, this one right here. 1 is out. So we do this, and we do, actually, we bring it a little bit closer to the center, and we big old triangle, actually, that, and that. This one kind of wraps under, and this one goes up and over, and then this one is plus, and then the same thing on the other side, but off by one row of pins. So this one would have, this would be minus, so V minus. This one is V plus. You can see how there's a capacitor right there. And then the pin on the end is, oh, so this one actually faces the opposite direction. Yeah, our in pluses and minuses are, okay, so that gives me a little bit of room to draw. I can draw right here. I can go like this. This one sneaks under. This one goes around like that. And this one is plus. There we go. So that's a dual op amp that we've just drawn in very few pixels, and not a lot of them are interpretable, but it's at least something that we can see in the schematic. So how is that arranged? Well, that's the output. This one is the inverting. So that one might feed back, and it might have more connections, like the ground and stuff. Yeah. I see what you're doing there. But that'll be something to suss out with the multimeter, the multimeter. Absolutely no angles on your little T-junction right there. I'm appalled. You can't even make it look fancy. And they were getting how much for these? It's like a really expensive, I mean, it's discontinued, I think, now, but M303. Not schematic. We couldn't find shit for that. That's why we're doing our own. PID auto tune, right? That's a different piece of equipment. M303 Acid Labs. $600. Well, $10 for that one. Maybe that one's blown up. Wait, $99 minimum order. Can I get 10 of these things? That would be kind of cool. Oh my god, I could make the Blade theme all day, every day. JMax Supply. $99 minimum order. I don't know if they're listing what they think. Lab M303. What the? A minimum order requirement of $99. Is it just a picture? Is that what, am I buying a picture of an M3? Top pins. Lab M303. CR Lab Master top pins. 5.0 based on 3 reviews. Do you guys think it's a $10? What are these things? I don't understand. From what is JMax Supply? It's an industrial supplier. If there is somehow a mislabeled, oh, do they just sell like whatever? No, this seems like it's more of an industrial supplier, which would be absolutely mind-boggling if they listed the actual Acid Labs M303. It's like somebody was trying to sneak something under the carpet. Oh, I know a tenner is way too cheap. I understand. Is it just the faceplate? It could be just like a mislisting. Although this does have JMax watermark all over it. What does that even mean? There's no way. It seems like, did they mislist it? Should I be trying to buy it? They have a minimum order of $100, but it's like I could get anything else on this website. Like an electrified crash bar. Look at that. There's no way. There's no way it's an entire M303 from one. It's got to be like just the faceplate or something like that. But you can't just get the faceplate. Yeah, exactly. Give me $10 and I'll just kind of consider that. If it's a mislisting and I just go to fucking like order it, delivery by Tuesday. And it somehow has a good score. The related items, that's what I'm wondering too. The other related items were like soldering stuff. This one is all chemicals. Sigma Aldrich acetylate. Acetylate. Uncle Phil would know what some of this stuff is. That's a really weird listing, and that threw me for a loop. I shouldn't have shown any of you that, so I could try to order it. No, it was minimum order of $99, not minimum of $99 worth of this item. It seems like in order for them to go through the trouble of putting together a box of stuff to send to you, then it would have been, you need to order $100 of stuff. This is more like it, $674. Is it actually a minimum of 10 units? See more details at JMax Supply. There's literally no other details. In order to keep our prices low, we have a minimum order requirement of $99. I think that means overall in your cart, not 10 of those, which would be hilarious. I'd still order 10 of these if they were going to, be the full thing. I'm of a mind that this is some kind of a mislisting. No reviews. If you went to order that, they'd probably be like, oh, it's not actually in stock. Yeah, total cart. That's what I think. I should put together a $99 cart and just take my chances and see if I accidentally get an Acid Lab M303, because that's what they list. It's probably like a Switch or something like that. This is other stuff from Lab. Wait, I didn't mean to search it on Google Shopping. Hold on. JMax Supply. No. I mean, from our perspective, one would hope that they just didn't know what they were listing and they listed it for $10. But something with that many knobs and switches on it would definitely not go for that price. So all things considered, it might just be a part number, and then somebody looked up the image for a part number and found the Acid Lab M303 and listed it without thinking. But boy howdy, if the odds are in our favor, you could end up with something pretty crazy. I don't know if I trust that though, because I'd have to spend $100. Although I could probably pretty quickly put together a $100 cart of random bullshit from an industrial supplier. That would not be that difficult to do. But it seems as though you'd be taking a little bit of a risk. Sometimes those listings, you'll go to buy something that's too good to be true, and they just disappear the whole thing. They'll just be like, oops, here's your money back, deleted. I've had that happen with some stuff before, but you know, how cool would it be if they actually, this industrial supplier somehow had a stock of this specific module? At that point, I would toss all of this data that we just gleaned off of this module in the trash, and I would just give Dave the module and be like, we're done. I'm not dealing with this thing again. The other one would go in the trash, and we'd never talk about it again. That would be very nice. That would really get something off of my plate. I don't think we've missed anywhere. There's a couple areas that I need to ohm out in order to figure out what's going on. I'm hitting save. Oh, wait, let's get some of these that I've missed. Some of these little ones that I missed. I know it's like buying magic beans. You're correct. But what a cool story that would be for my wallet. Yeah, I got like 5 of these $600 mods. You don't know how many they have in stock. They just say it's in stock, which could mean that it's a complete mislisting. It's probably like an e-clip that's for like some other industrial thing. Looking at the other lab brand supplies that they listed, it looked like a bunch of like organization and solder helping things, like sort of vaguely related to electronics, but not quite. They were like more universal kinds of things. So it could be that it's just like a label for something. Buy 10, and if it works, flip them on Reverb. I would be a millionaire. Like exploiting stuff in Fallout. I'm just looking for any other traces that I've missed. There are definitely some things that I need to ohm out. I need to find out what's going on beneath some of these chips. And this one's going to be the more interesting one, because this one we don't know. Question mark, question mark. We don't know what this is. It is in the area of what might be a diode ladder. I'm kind of suspecting that this is a diode ladder. I'll have to look up some diode ladder, drawings in order to figure out what exactly is going on. But like, what are you? This is a fascinating circuit right here. Don't think it's a 556. I don't see the capacitors for it. And if it's an op amp, why censor it? Pins 8 and 11 are connected to something. Yeah, I'll have to rearrange and organize this a little bit and see if I can't pull some structures out of it. Getting power and ground together is one thing, and then the next step for this would be in another layer. I can then mark down where all the bottom layer stuff is, and of course I keep the top layer up just so you know what's where, so you get to mark out where the grounds are connected and stuff like that, and it helps you narrow down the things you still need to figure out in this circuit, like what goes where. Anyway, I'm going to save this and we'll come back to it some other time. It's been very tiring working on this thing, but it's been fun shooting the shit with you guys, because boy, this kind of work is like ADHD brain food. You get to sit down and hyper-focus on tracing something that's a completely mindless job, but at the end of the day, it is very tiring, and so I am feeling it now. So we're gonna break. I'm gonna go touch grass with the puppy. You guys have gotten a good little view into utilizing some weird tools in order to get us a circuit layout, and then figuring out from there what the exact design is a matter of just reworking these elements until they look like something that's familiar. And so we'll do a little bit of that some other time. You guys can kind of see my brain process as I kind of work through some of these things and do a little bit of research, because I don't know what I'm looking at. I don't know anything about what I'm looking at. All we found out today is that this voltage regulator here is built almost to the same position as the schematic that's in the datasheet for the chip. Almost to the same position. Yeah, Willow walk time. We do have a couple of Willow moments now. Are anybody doing anything? Gonad's here, so I know he's not streaming. Actually, that's not determined, is it? He could possibly be here and streaming at the same time. He's done that before. All bets are off. You're having a day off. It's good to take a day off. I should take a day off. Paleontologizing's up. You guys should check out Paleontologizing if you're interested in dinosaurs, because he's kind of a knowledge fellowship guy that does a lot of cool stuff with, I don't know, dinosaurs. I don't know, man. It's dinosaurs. You guys figure it out. Okay, I'm done for the day. Here is the end card with social media related things on it. I don't know if I'll get around to tweeting. I tweeted a couple pictures of Willow, I think. Yeah, Notes and Volts. Oh, you guys can check out Notes and Volts too if you want to really see some music related stuff like that. But I gotta go. I gotta run. Thank you guys for joining me. I will be back tomorrow. Tomorrow, because we failed at the fish noise. We failed. We didn't make the fish noise. We're gonna try to do something easier. I'm gonna try something a little easier from that book. There's some easier stuff in the book. We'll find like an oscillator. Just like one oscillator, and try to put that together and actually get it to work, because my confidence is completely shook from not being able to get something stupid and simple to work. So it's time to kind of dial back, relax, put together a test setup, test it, have something cool go on. I like the waving one. That's neat. I will see you guys tomorrow if you can make it. If not, then I won't see you. Well, maybe I'll see you. You won't see me, but I'll see you.